And I will not make it any longer than necessary because we have a very nice but very busy program for today. So welcome everybody. We had a good day yesterday. We had a good dinner together, and today we hopefully are awake after working all night and preparing the presentations for today. We have a day full of surprises. The program you got already a few days ago, but there has been some minor changes. We will start in a few minutes with the first session. As you see, the program is consists of 4 sessions. The first one will be more on the general issues of how to proceed with the advancement of the model code. We have a few speakers, including Hugo, who will represent the presidium of FIB. So we will have some thoughts from our leaders, the leaders of the scientific community. And then we'll continue with 3 sessions that are more on the technical issues and discussing the scope of the technical advancement and defining the topics that we should be working in the coming period. The first session, the one that should start now. As you see, we will have 3 speakers, and I will give directly the floor to Hugo, who will be our first one.
Okay. Okay. Good morning, ladies and gentlemen. It is an honor for me to welcome all of you here in Netherlands in this very important meeting. I think it is a very important meeting for FIB and for our community. Our president, Harald Müller, was not able to participate in this important meeting, so I will try to represent him. I will make a very short presentation trying to summarize some of the general discussions we had during the last meetings in FIB, and not working. Not working. Yeah, now it's working. Okay. So I will try to summarize some ideas we were discussing in the last meetings in FIB, and I will give you also some personal ideas about this subject. I would like to start with the idea presented in the last technical committee by our president, Harald Müller. He was explaining us that our first recommendation, CED recommendation, was published in 1964. Immediately after, 6 years later, we had a recommendation, common recommendation between CED and FIB. 8 years later, the first model code. 12 years later, the second one, and 20 years later, the last one. So we need to improve our system to update the model code, because the model code is our most important document, and we need to find a way to make shorter the time we need in order to produce a new edition. We had in the Presidium the proposal to work in a model code for assessment, interventions, and management of existing concrete structures. From Commission 3, Stuart made a very clear presentation in our last technical council in Copenhagen. He will have another presentation today, updating Commission 3 proposal. We had also a proposal from Jos Barraven to make examples using our model code. This was done many years ago when we published the first model code in '78. I participated in the examples 30 years ago, probably, and it was very useful to check the document, and it is a good idea today to start working in some examples, and Commission 9, dissemination of knowledge, is in charge to do that, and we need to take advantage of this activity. And we have also some translations. Now it's published with the Polish version of the model code. We are finishing our own Spanish translation, and if you face a document in a global view, you can see inconsistencies, and you can have many good inputs to improve the document, and we need to take advantage of that too. Well, anyhow, we have a very good document, which is better than the previous, much more better than the previous version. We cover in a more consistent way newer structures, but we were trying to treat the problem of existing structures. We need to improve the treatment of that problem, but at the same time, we have a good base to complete this document. We have consistent models. I want to show the example of shear. We really wanted to avoid empirical models. We wanted to have rational models, and probably this is the best way to make those models applicable to all type of structures with different materials. We have very good basis to extend these ideas to existing structures, and I think it is very important to maintain this policy. We have also implemented this system with different levels of accuracy, and this could help a lot as in the way to treat existing structures. So this is another idea which is new, and it's very important for the future works. There is a discussion if the code in some chapters is like a textbook, and we need to try to make the code in a more code format, and we have at the same time many different ways to publish previous documents in order to really show more in detail the ideas we will propose in our model code. So we have, for example, the textbook, we have the bulletins, and also structural concrete. And probably, surely, during the day, we will see many other good ideas we can take into consideration, we can use, and we can improve. So let me make a short, very short introduction, not introduction, but explain my ideas. We are here in 2015. We have a new model code to design new structures. We have some good ideas to manage the existing structures. We have some ideas when we reach the end of the span life. But we were discussing when a structure is an existing structure, and according to the discussions and my own idea, one structure is an existing structure when you start the construction of the structure, because when you start the construction of the structure, you could have problems. This is an example. These are beams which were cast or precast in Canada, and in this country you have a very aggressive environment, and you need to measure the cover. And when you measure the cover, you need to control the cover. When you do that, you need to assess the situation, and you need to take decisions. And this process is similar to the process you need to use for older structures. So I think this could be this. We need to discuss that, but at the same time, from my point of view, is a good definition of an existing structure. We have now some indications to manage the existing structures, and you have a strategy to building maintenance management. And when you have a structure like this, and you make inspections, the first stage of the assessment, then you find problems, and you need to repair or to take measures. And we need some more information in our model code to face these type of problems. In some other cases, you need to use existing structures to increase the span life. And this is a case, for example, it was a structure which was built in 1988, and it was decided to widen from 12 meters to 24 meters, and you need to assess, you need to collect information, you need to be sure that the structure is able to resist new loads, and then you need to have new ideas to manage this problem, and then you need to be very careful in the construction, because the construction of for these kind of problems is more difficult, and you need to use very difficult different procedures, and but at the end you need to solve the problem. And in some other cases you need to use this is a building in Madrid, and it will be stored in few months, and we needed to assess that building, and the information was not so good because we had not practical information, and the problem is completely different, but we need to solve that problems too. Giuseppe made a good presentation in Copenhagen, and at the end of the day, of the lifetime, in some occasions, this is a building which was built at the beginning of the 20th century, and after the inspection and due to the damage of the bridge, we decided to demolish the bridge, and this is a good occasion to learn again about the materials, about the systems of construction, and so we are doing that every day. It should be very important to have all the subjects solved at the very good level, but we don't have that, and we have to do this every day. So I think, as a conclusion, I think the revision of the model code is a must for FIB, and it must be addressed with clear objectives and a limited and well-defined deadline. This is very important. The proposal of Commission 3 establish a revision and update of a current model code for existing structures is very important initiative and is welcome. This activity involves all FIB commissions, and thus it must be addressed by the whole FIB. This revision may enable, alongside other initiatives, such as the preparation of model code examples, with the translation that has been or will be made to verify in detail various parts of the document and improve it. Evidently, not all issues can be treated at the same level, and not all of the necessary issues can be solved. Nevertheless, FIB has the responsibility and the possibility, as it has done in the past, to provide ideas to adequately address existing structures. We should have in mind that existing structures is a subject that, with or without our contribution, has to be carried out by many brave structural engineers every day. And we need to know that we need to be really humble. We know a little bit, we don't know a lot, and we need to avoid this situation. This is the quantity of information needed by Maya to build this bridge, and this is the quantity of information our colleague Jean-François Klein needed to develop for the rehabilitation in 2010. Thank you very much.
Thank you very much for this presentation. I think this is the excellent start of day. You mentioned a number of points that will need to get our attention, like how to change what needs to be changed and you make use of this what is already available, how to establish cooperation between different groups working in FIB, and how to define the scope and the process that will make it feasible and will help us and not make our work more complicated. I hope that with the two next presentations by Stuart and by Steve Denton, we will get to the point that we will have a discussion with all of you on this essential point, and we will be able to come to some conclusions and then continue with the technical part of the day. So Stuart, the floor is yours. I will have you.
Yeah, where are we?
Wait a second.
Yeah, so I'd just like to say thank you, Hugo. It was a very nice presentation. It's helped set the scene for where we need to, or what we need to bear in mind as our audience, our ultimate goal, and some of the wider scenes for us. So, can't see. Hang on, where's the start on this?
Okay.
Oh, sorry. You're seeing something completely different to what I was seeing. Right. So, welcome. Good morning. Apologies for that confusion. So, the proposal was made, as you heard, and the goal agreed that we should be looking to produce a single merge code for both new and existing structures. So I think that vision is accepted. And obviously we do need to build upon what we've achieved so far in Model Code 2010 and the embryonic treatment of existing structures in Chapter 9 of that document. I'm hoping that this workshop will, by the end of the day, help us define what the requirements are for the modification, the way forward, and how we will go about delivering what I think is an ambitious project. So, in terms of a roadmap, what we are seeking to do, so I can't really work this like this, is establish, or we recognise that what we're going to establish is the inclusion of existing structures as the primary goal, but also the process needs to be open to the possibility of other amendments and other revisions. So we're looking for suggestions to amend the structure, the content of Model Code 2010. We'll obviously need a project management structure, and the suggestion is set up a stack, Model Code 2020, snappy, obvious title, a plan for project delivery and a proposed schedule, and to identify the support needed to deliver that. So that's our goal, really, to come out of or be informed of your opinions so that they can be incorporated into that outcome. Hugo said that's where we started, so I'll nip over. It was recognised in Model Code 2010, in Chapter 9 on conservation, the need for potentially parallel paths to deal with new and existing structures. So we have already started on this path before. You'll see here new, existing, but a number of commonalities in the following parts of the process. Hugo's identified what the structure of Model Code 2010 is at present, and Chapter 9 comes there towards the end. But in reality, if we're going to integrate the processes associated with existing structures, they need to be brought in throughout the body of the document, because it has influences at different parts of the process of the different activities. So very boldly, I had a thought, or some thoughts, what might a Model Code 2020 look like? So jumping in at the deep end, I brought together some thoughts, just as a basis for perhaps later discussion during the day, but to hopefully provide some focus, something to react against. You'll see this. You'll see that the structure, the parts are basically similar, but the idea is to integrate in new parts as appropriate, as debate, identify the issues. And here I've just very simply identified whether it's new, whether it's based on Model Code 2020, whether it's shared and extended, greatly extended. So those sections, those chapters are essentially similarly divided, with following parts: design, construction, conservation, This would be, I think, significantly different to what we see at the moment, but you would recognise the same themes, but developed in different ways. And obviously we still need to address the underlying verifications for safety, serviceability, durability, robustness, sustainability, etc., as we have been working on in Model Code 2010. So what needs changing in Model Code 2010? I think the debate that's gone on over the last few days suggests that not all is okay. There's a lot of good things. There are a number of points where we could improve things. So we're seeking your ideas, obviously in the following sessions. But should we be more radical? How radical should we be in our aspirations in terms of integrating the processes into one document? What will be a step too far? Do we need to integrate seismic assessment? Do we need to introduce a sustainability verification procedure? I think we'll hear something later, integrating the fibre reinforced concrete verification procedure into the document. Obviously, there's been a lot of discussions about robustness here and elsewhere. We were talking yesterday about the need to improve carbonation and chloride models and other models as well. Other debates throw up a need for this process, a procedure for selecting remedial materials, remedial techniques. So a long list. Now we will hear subsequently from Steve, I believe, on the concept of a general code. So we'll weight his ideas and how extensive and radical they might be. The themes of the session today in the programme, I've simplified it, but here we are at the moment, general introductions and code advancement. The code parts that the different areas might contribute to are identified, so we're sort of going through the primary parts of Model Code 2010 and gathering ideas as to what might be relevant, what we might need to do. Clearly, this part at the end, this workshop summary, is going to be a very critical thing. So we have Gary, hopefully distilling out some of the points, recording it during the day, and hopefully we'll have captured the essence of what's being said and report that back to you at the end of the day and in some subsequent notes about the meeting. I showed this, I think, yesterday about the basic timetable with the goal of delivering a final draft in 2020. Obviously, the debate and the process that we need to go through to identify what changes are required will bring into focus how practical that is. But I think the debate seems to suggest that it's a reasonable target. So how do we organise the work? We're starting today the workshop, discuss the draft contents, identify potential authors maybe, routes for obtaining contributions. We believe, to create a coordinating drafted body of SAG 2020. There is a need for a technical secretariat, as there was for SAG 5, for the development of Model Code 2010. We clearly are seeking to gather input contributions from the whole FIB family, and we may need to collaborate and seek contributions from other bodies. So we need to establish coordination, liaison mechanisms. So what I'm looking for us to do, I think, is to establish a vision for what Model Code 2020 might be as a single merged document. We need, as I say, to engage with the whole FIB family. We need to spend quite a bit of time if we're going to do this for planning and coordination, and a SAG Model Code body will certainly help draw everything together. We'll need a team of active and willing authors, contributors. We're looking for this list of topics, design contents, suggestions today. How do we establish a shared vision in the future? Maybe we need to have another workshop or a series of processes to help us bring these things into focus, and so that we all understand our part. We're obviously going to need a contents list at some point. We need better ways of working, maybe targeted workshops. That was suggested in the debate yesterday. We certainly need to improve the efficiency with which we can work, if we can use web meetings and other things. So what we will look to do after today is develop a plan to look for means of delivering this timescale, taking on board the advice, the guidance that we're going to get from you and others. So thank you very much.
Stuart, thank you. Maybe you can keep this on the screen for a second, because I think we are now at the moment that the discussion can start. We had a proposal, a vision, a definition of the needs from the Presidium, and the way to approach it, one of many possible ways how to approach this process. We can now go both ways. Either we will have now a moment for questions from the audience, or I will ask Steve to be the first to take a part in the discussion with his feedback and ideas, and maybe we will proceed like that. If you can help us to start, please be critical and supportive.
Sure.
And then I will ask all of you to give your ideas and feedback on everything that we have heard until now. Ideally, in the end, we will be able to agree on the possible roadmap, how to proceed in the coming years, as the timetable of Stuart reached up to 2020. Yeah.
So that's forward.
Yeah. Okay. Great, thank you. Good morning, everybody. I'd like to start off by thanking you for the invitation to come and say a few words this morning. We only have a little bit of time, so in a way, all I can do with you is share some thoughts. So for my introduction, my name is Steve Denton. I'm the head of Bridges and Ground Engineering for WSP Parsons Brinckerhoff. Also the chairman of SEN TC 250. And I think it's important, kicking off this brief presentation, to explain that what I'm sharing with you today is very much a personal perspective. That there is work ongoing within SEN TC 250 to develop Eurocodes for assessment, or aspects of Eurocode material for assessment. And I'm not going to touch on that today, but I want to share with you some thoughts that really emerged through the conversations that we had in Copenhagen at the FIB Technical Council meeting. And really as a contribution to the debate, and I think that's important as a contribution to the debate. I think my starting point here is to recognize the role that FIB has had in shaping the way that what standards do, the way they are presented, the content of standards. Obviously, hugely amongst the community, the concrete community, but also FIB have been tremendously influential in shaping practice beyond concrete structures. And I think that there is an opportunity here for FIB to embrace that same level of ambition and to think about how FIB can actually influence the future shape of standards within the concrete community, but also beyond it. And so what I wanted to do this morning was really just to share with you some thoughts which in some ways are a challenge to us, to question whether we can think in new ways about the way that our codes should be structured and what their needs truly are. And it touches, what I've got touches quite closely on a number of the points, Hugo, that you made in your presentation, albeit presented in a slightly different fashion. When I was thinking about this, I was thinking about the evolution of codes for assessment. And my experience, and this is a field that I've worked in for about 23 years now, and my experience was that the first generation of assessment documents really were developed as sort of subsidiary documents to design codes. But the design codes existed, and then the recognition of this need, and that really at the start, we tried to use design standards for assessment. We realized that that didn't work very well, and then there was sort of complementary assessment standards that were produced, and that was for the first generation. But there were issues with this. The first issue was that really there was a failure to recognize that fundamental difference between designing new structures and dealing with existing structures. That typically, when our starting point were the provisions of design standards, we ended up with very conservative assessment results. And we also struggled to deal with the actual materials that we would encounter, the way that detailing had actually been done, the tolerances that may have been achieved during construction. We really didn't have the provisions to enable us to deal with those issues. And that was a significant problem, and certainly in the UK, some of those issues, just amongst the bridge engineering community, led to tens, probably hundreds of millions of pounds being spent on structures that possibly didn't need to be done because we simply didn't have the understanding and the tools to be able to assess existing structures as accurately as they merited. So then things progressed, and then we moved essentially onto a second generation of standards. And in the second generation of standards, design standards and assessment standards, and they're sort of complementary, but they're separate. And this is a situation, I think, in quite a lot of countries now. But this too has some issues. One of the issues is that we get quite a lot of duplication of content. But what's intriguing is that we get some duplication of content, but we also get some omissions. So Hugo, in your presentation, I was thinking about the case you had in Canada, and when you start thinking of a structure being an existing structure and needing some of those assessment provisions, actually in our design standards, we don't include those tools for dealing with issues that you encounter during construction. To some extent, we have them within our assessment standards, but if you see where I'm heading, you see that actually, by having these separate documents, we have some omissions from both sides of the family. That there are things that we have in assessment standards that can be very valuable in design, and there are things we have in design standards that could be valuable in assessment in special cases. But by having them separate, we omit these things. And we have a fundamental problem with what happens when you make an intervention. So if you use an assessment standard to assess an existing structure and you determine that some intervention is necessary, what do you then do? Do you design it using your design standard? Because if you design it using your design standard, then how does that fit if you're reusing components of an existing structure? It gets terribly messy. Terribly messy. All of these things are resolvable. They're resolvable on a case-by-case basis. Probably everybody in this room has got these issues. We know that they're issues. We know they're complicated. They often lead to quite extensive dialogue with clients. We have to decide our basis of what we're going to use. Isn't there a better way? And so my question is, my suggestion is, couldn't we look to be a bit more ambitious here and ask how much is common between these different questions that we need to answer, the questions relating to design, the questions relating to assessment, and also the questions relating to interventions and modifications. How much of this is truly common? And that part which is common, couldn't we write that into the general provisions of the future code and then complement that with the material that deals with the application of those general provisions in the context of design, in the context of modification, in the context of assessment. Now that's a very simple diagram. I'm really conscious that with the limited time we've got, actually what makes this real is when you start thinking about what this actually means. So I tried to go a little bit in that direction. What would this mean if we went down this route? So the first thing is that those general provisions would need to be applicable for design, assessment, and interventions and modification of existing structures. Now, if you're going to do that, then those general provisions need to be explicit about the conditions that need to be satisfied for them to be applicable. So let's think, what does that actually mean? What that actually means is that in a design standard, we'll typically make some assumptions. We'll have a resistance equation, resistance formula, resistance approach, resistance model that relies on certain detailing provisions being satisfied. Now, in a design standard, we don't need to define that linkage because we simply say detailing provisions need to be satisfied. Here is the resistance model that you can use, and we don't need to be explicit about the coupling between the two, because if the designer is using that code, then they will be satisfying both, and we know that will be the case. One of the challenges with assessment is that you obviously encounter those situations where perhaps those detailing approaches, which are an assumption in a design resistance model, are not going to be satisfied. So if we're going to go down this approach that I'm suggesting, we actually have to think very, very hard when we look at our resistance models and say, what are they assuming? And we need to be very explicit about them. Now, if we take a really simple example, we could look at anchorage of reinforcement. What is it in our resistance models? What expectations, what reliance do they place on reinforcement, for example, being adequately anchored? Now, in the design case, it's straightforward because we just say you need to anchor the reinforcements and we give the designers tools to be able to make sure that happens. In the assessment case, actually what we could do is we could write our provisions being explicit about the fact that we're assuming that or we're relying on a certain level of anchorage being achieved. And then if we look at the assessment case, then we need to give people the tools so that if that isn't satisfied, if the basic requirement isn't satisfied, then there's an understanding of what the implications would be for the resistance models. Or you could look at it another way, so that the general provisions need to allow account to be taken of actual materials, actual detailing, actual tolerances that may be encountered on existing structures. Now that means that our general resistance models, and I'm focusing on the resistance models, I think they're the hardest, that our general resistance models would need to be written in a more general fashion. That they would look more complicated because they would have to cater for the more challenging general problem of the assessment of existing structures, because we have to recognize that that is in some many ways a harder problem than dealing with new design, because new design have control of materials and with detailing. But if we had those general provisions that were presented that we need for the assessment case, then of course our application parts can simplify those for specific design cases. So you may have a quite complicated general approach, but then have the ability to say, but of course in design, these parameters are fixed and this shrinks down to a simpler expression. Now, in a way, what I'm suggesting is that what we can do is embark on a process here, that we can look at the provisions that we have at the moment, and we could challenge ourselves to say, how much of this could we raise into this zone of general provisions? And how much do we need to handle that's different for design, that's different for assessment, that's different for modification? And I guess what the challenge, if you like, the question that could emerge from this is actually, if we can capture most within the general provisions and the application of those into design and assessment becomes a relatively smaller element of the document, then that would indicate that we've succeeded or that this model works. If, in contrast, what we find is those general provisions are very thin, they're very generic, they're not very helpful, then this model fails. And the exercise I think one needs to do is actually take these on a case-by-case basis and say, what is possible? How much can we get to this sort of position? Or is it not going to be helpful for us? But I think if we don't move towards this model, and I think, Stuart, one of the challenges with the content that you presented was, do we actually end up with something that looks a little bit like, well, that feels a little bit like this, but is just amalgamated within one publication? Or can we move to something which looks a little bit more like this conceptually?
More that way.
Yeah.
Yeah.
But
although,
I think,
yes.
But the interesting challenge is, how do you make those general provisions helpful? Yeah, how do you make it so that, because you could look at this, and this looks, seems a very kind of simple philosophical point. The devil is in the detail, and the interest is in the examples. But actually, what this requires us to do is to think very fundamentally about what is general, what is common, and how do we write those things in a manner which means that they can be applied, perhaps with some simplification in the case of design, or perhaps in the case of assessment with some invitation to undertake further exploration of a structure, or to measure certain parameters, which make them helpful on the assessment side. Can we achieve this sort of model? Is an interesting challenge for us. And the final thing I wanted to say was that I think when you look at this, and you look at that idea of general provisions and application for design and separate parts, I would be amazed if many of you aren't looking at this saying, isn't that a mess? Isn't that difficult for designers? Doesn't that mean we've got lots of documents? How do you navigate this? Which of course is an issue for us. But I think the other challenge, the other bit of context that we need to recognize, the other opportunity for us, is to think that actually, by the time we get to 2020, and 2020 might be a little ambitious, a few years on, actually, how are we going to be working? When you look at Hugo's timeline, is Model Code 2020, 21, 22, is the picture of that going to be a bound document, or is that actually going to be information on a tablet? And if it's information on a tablet, and if we're working electronically, then actually it doesn't matter how long a document is. What matters how easy it is to navigate within it. So that if we can create something which is a very rational and regular structure, it doesn't matter how many pages they are, because from a user's point of view, you can navigate through it and get to the information that you want. So I don't think we should we shouldn't premise our thinking necessarily on what the paper edition might look like. That's probably enough from me.
And I think please stay here
Yeah.
because I think now we are where we wanted to get. Thank you for starting this discussion. We thought we had a challenge, but you added one more challenge to the one that Stuart has defined. I propose the following. I will hand one of the microphones over to Stuart, and I will invite all of you to reflect on what you just heard. So are we accepting this challenge? Do we want to create the code, which is really the future generation document, which where we embrace this ambition of having general provisions that are not only philosophical, but also have the meaning for the code, that are really the foundation for our code? Do we see any examples where it can be done, on which fields it can be done? I know that later on during the day we will discuss in more details these different fields, but maybe we can simply do some check. What is the feeling from at least these 4 domains that we have defined? So Stuart, this one will be yours. We have one more microphone in the room. So who's first to share his view? Yeah, Kunal?
Can I just say something before you start? I think our thought processes are more aligned. There are also issues about that we thought about in terms of maintenance of the document.
Yeah.
So there's a whole series of things that we haven't revealed.
Thank you, Steve and Stuart. Thank you both. That was a nice presentation. I'm trying to be playing a role of devil's advocate here, and I like the concept of unified code, but still I want to rather kind of counter argue. In the name of unified code, we are actually dealing with three safety formats at the same time. For example, we are designing a new structure for strength and serviceability, one safety format. We'll be assessing an existing structure, another safety format. We'll be intervening and we'll be providing some structural strengthening for that, the third safety format. Uncertainties, philosophy, and the basis are largely different for all the safety formats. And how we're binding all these things together in a single document so that the structure remains consistent across its service life, right from its created for the first time, it is assessed at some point along the life, and it is modified, and further it is further modified at later stage.
Yeah, if I could first on that one, because in part I'd like to challenge the question. That why would we have different safety formats? That shouldn't there be one general safety format that applies in all cases? And then there are some special characteristics. So in the case of design, that safety format has to interface with the way in which we specify materials, for example. And we need to make sure that the safety factors or whatever that we use mesh between the way we specify materials and the way that we take account of uncertainty within that safety format in the design case. In the assessment case, we obviously can test the materials that are there in practice, and again, it's a slightly different situation, but fundamentally, are we not just dealing with uncertainty in the properties of the materials, and therefore, why can't we just wind them back into the same unified safety format? Now the risk of taking them into a single safety format is when you first look at it, that single safety format might superficially appear a bit more complicated. And that's why I was saying that actually what one can do in the case of certain design situations is potentially to simplify it down, and possibly the same on the assessment side, although it's less straightforward. So we can show how this can be simplified. But my feeling is that what engineers value are things that are rational and consistent. We're kind of good with rational and consistent. And I would rather have the complexity of a longer expression with a few more terms in it, but be able to make the mental leap to say those are not these particular parts are not relevant to the question I'm looking at, than to get two equations which look similar, have differences, but I don't have the transparency of where the differences exist. So that's my thought process. There was another important point to your question, And the other important point to your question, I think you were talking in terms of safety formats, but actually, in your question, it drifted a little bit into objectives. You talked about safety, also talked about serviceability. We could also talk about durability. That for me, actually, those are objectives. And our objectives when we're dealing with existing structures can be different from our objectives when we're designing new structures. That to make that practical, make that real. If we are designing a structure, then clearly we need to make sure within our design that what we have is something which is safe, serviceable, robust, durable. When we're dealing with an existing structure, what do we do about the durability question? Does it actually make sense for us to do a durability assessment of an existing structure? In fact, does it really make sense for us to do a serviceability assessment of an existing structure? The reality is we have a full-scale model out there doing its job. Isn't it actually better to deal with the serviceability questions through examining the existing structure rather than doing some kind of theoretical model, recognizing all the uncertainties that we have within our serviceability models, which are that much worse than ones within our ultimate inner-state models? So I think it's valuable to recognize those different objectives, but you can still all wind them back, or can't you? That's my question. Can't you wind them back to the same underlying philosophy, the same underlying unified principles that we're trying to satisfy?
Giuseppe, would you like to ask?
Yes, thank you. Thank you, Steve. I agree your proposal. In particular, I agree the bigger rectangular for general provisions because I think that now is the case to be very transparent in the code. I remember in 78 Model Code, we had the initial part, the first chapter, which was related to the reliability aspect, and all was clear. We need the same treatment here. That is, we have to explain clearly what are the uncertainties in the new, how we treat the uncertainties in the new structures and the existing structures, the differences, very clear there. To introduce something also about the risk analysis, because this is necessary for the robustness, for instance, and then the engineers must manage the probability accepted by the society to loss of human life in different situations. And then in the code, you have a simplification. Then when it is clear in the general provision that the beta factor, the probability of error, and so on, assume these values, and the way to derive the gamma factors is this one, very clear, then you can simplify the design approach for the different type of structure. We have now, it's been developed about 10 years ago, but it is in development, the probabilistic model code, in which such concepts now are very clearly exposed. There is the appendix on the risk analysis also, which is very clear. And I think it's the moment to add in our code such important chapter. We have the fortune to have several young peoples, which works both in joint common of social safety and here. And this is the moment to update, to increase the quality, the general quality of our code respected to this problem.
So definitely this, if I can use your microphone first. So definitely there is a feeling that the fundamentals can be created. Yes, at least the safety issues, the safety philosophy can and needs to be harmonized.
I think there is a risk of misinterpreting this model, which I'd like to just address. And it's not, Giuseppe, that in any way what you said is a misinterpretation of it. I think what you said is absolutely valid, and it makes up a portion of the general provisions. But actually, for me, there's a much bigger part of the general provisions which is important, and that is where we actually get into some of our basic resistance models. You know, the model that you put up for shear. You know, how do we generalize that model, and how do we present it in a way that it explains what we are expecting of the detailing in that area?
So it's good, thank you. So you challenged us once.
Yes,
we thought we were there, but
Yeah.
you are challenging us again.
Yeah.
Conrad.
Let me divide the intervention in two pieces. First of all, I would like a little bit to reflect the past and going to the proposal of the future. I have a feeling that we are promoting the different codes still as a teaching book. And if you look a little bit to the national codes, they are getting bigger and bigger, and they're not readable anymore. So coming a little bit now to the proposal which was presented, I feel very comfortable with a so-called general provisions, taking into account explicitly the general design. And we have to fix there also the whole process of acceptance risk on a system basis and not on a cross-section basis. And taking into account all the different issues like uncertainties, tolerances, and so on, this gives us a little bit a chance to follow the design process. Optimization is a big issue. Then we need some basic input data, probably as a default data. If I remember that we classified our concrete strength into C2025 or 3037, taking into account that we are accepting in Europe, in Germany, the alpha factor 0.5 or 0.85. In Austria, in our country, no, it's 1. So that doesn't make any sense anymore to have a classification of concrete strengths. And this should be taken into account in the general provision. We are able also to produce now concrete on a dynamic basis. And I would like to introduce the modeling and the checks of models, which is a very big issue as well, general provisions. Second issue, about the different, let's say, modules which have been presented. I really agree on that. And the kind of modulus should be focused for the new design, for the maintenance, ordinary maintenance, inspection, modifications, assessment, and so on. And those modules could be developed on a, let's say, on a digital basis, and they should be promoted as a dynamic modulus, since a lot of new materials are all the time introduced. And so if you would have a general provision, a general code, which holds a little bit longer, 10 years, 15 years, and so on, and the different modules could be added on time as know-how is produced and as experience is actually taken into account.
Thank you. Stuart, can you reflect on this last comment? How does it, you will get this one, how does it fit in the concept that you have presented? The structure, the table of contact, you were putting some forward?
I think what I was putting forward is pretty consistent with what Steve has said. Obviously, we've had some discussions over the last couple of days and over the last weeks about that. Clearly, the basic structure of the Model Code 2010 allows general provisions at the start and increasing detail and focus on particular aspects. So I don't really see any inconsistency in the details that I presented. It would be useful to have maybe a series of general provisions within the different sections. It depends on how that's going to work. In regard to Kunal's question, I think at the moment we do seek to have a consistent safety format, in terms of verifications against a number of criteria. Maybe there needs to be more criteria added. So I think the underlying philosophy, the underlying premise is there. You brought clarification, more detail into that, which I welcome. So I'm fairly easy at the moment with what everybody's saying in terms of what we were thinking about more broadly. As I say, I feel that we've got to go through a process and spend quite a bit of time in discussions, trying to understand the different points, what we're trying to achieve, before we try and launch into a detailed program of work, i.e. the writing. There's a lot of stuff to be done in terms of identifying issues where we need more knowledge, how to unpick what we've got at the moment and build a better framework. These are not simple tasks, because you've got to step back and see the essence of what we prepared, because as you say, a lot of the time it's not as transparent. So I think it's going to be quite a difficult intellectual exercise.
Yeah, but I would like to come back to one of the points that Steve mentioned, that it's not only about general principles, but it's also about models.
Yes, sir.
And
Yes.
does anybody want? Yes, Steve.
I think the general provision is a little bit a black box for me at this moment.
Yes.
And I would like to go back to the start of the work of the model code 2010. We have said that the structure of the code should be logic, and it should be able to find your way for the designer or the persons who are doing the assessment. And therefore we have said it should reflect the life cycle. You should have the design, the conceptual ideas, the models, execution, and then you go to conservation and finally to dismantlement, even to make the whole cycle complete. And this is a logical way of thinking. And if we look to the concept that we had, I think it is worthwhile to see if we can use that as well. I think in Stuart's presentation, he did already a try keeping that structure and putting assessment and intervention somewhere there. I think that it is worthwhile to look if this is not a very good possibility, because it might mean that the model that we have can be used largely also in this respect by adding a number of things in a structural way, that we keep that life cycle idea. You can start with a new structure, but you can also step in somewhere and make cycles like.
Yes, I wasn't saying that I wanted to give up that approach, but I think you can bring in the general and these other factors within that framework.
Then this is not very clear to me. Where is the model code with that? The idea that we have now, is it in general provisions, and are these, because we have started already, the idea in community that we say, well, model code should be made, modified to be used for assessment and existing structures. And then we said we make another document which is giving complementary rules. And then after some time we gave up because it was not clear. You have to switch from one book to another. And now we are trying to have one model code with a basic idea, but the general provisions, I think it's for me much too vague.
Yes, yeah. Can I?
Because many of the models that we have, many of the rules that we have, they can be used integrally.
Yes. And this is so the term general provisions is potentially misleading. But if we only had a few minutes, a few slides, so it wasn't necessary to or possible to really unpick this. It probably would be better if it said general provisions stroke general models.
Yeah, but obviously you don't mean a chapter.
I don't mean a chapter. I mean what I mean is actually the philosophy of saying that in our chapter on shear. We have a general shear model. We have most of already. We have a general shear model, but then we also give the users the tools to be able to deploy that general shear model for design or that general shear model for assessment, and we give them the means to be able to go, and if they're dealing with an existing structure, we give them the guidance on how to extract, say, material properties from the existing structure in a fashion that's compatible with the general model, for example, and design we would simplify.
But the use of existing structures, even in this type of applications, shear, for instance, we had distinguished, I think, 4 levels.
Yes.
And the idea behind that was that you can take easy simple models for design, but if you want to judge on a bridge to see if it should be renovated or not, you take level 4.
Absolutely.
And that was the idea behind it. So a lot of it is already
absolutely. But it's there, but it's not necessarily transparent. that it's there.
Not yet, but
Not yet, but could be.
Yeah.
Can I just make one other comment, which is that in terms of the structure of the document, the structure of the document reflects the life cycle of a structure. But actually, from a user's point, it doesn't reflect a user's approach. Because a user's approach is that the user has a problem. I need to design a structure, or I need to assess a structure, or I need to look at a modification of a structure. At that point, they're not really thinking. They're not preoccupied with where they sit within the life cycle of a structure. They've just got a question that they need to answer, and we need to give them a means of navigating the document to find those answers. So there's a risk, if we think about it in a sort of life cycle fashion, that there's a risk that we actually end up duplicating content because we've got similar related questions that crop up in assessments as those that occur in design. And that's why I'm trying to ask that question. Could we philosophically come at this from a different approach, which is to say that when we're looking at SHIA, when we're looking at whatever else, we have a general model which is applicable, but we also offer those additions, simplifications that are suitable in the different cases that the designer might have or engineer might have.
I hope we will have some time during the day to illustrate this problem on a number of examples. And I still would like to continue with the session, but I would like to give you now the last opportunity to have some comments. I think Hugo wanted to say something, Carmen wants to say something, and then we would continue with the first case to take and discuss. We will look at this, the chances to have this fundamental general principles worked out for the principles of safety philosophy. But then first, Hugo, then Carmen.
Yes. Well, I like this slide because for me it represents the philosophy we have to follow, and the philosophy is consistent with his idea and your idea. It is my personal feeling. We need really to try to have only one document. We really need to try to generalize our concepts, safety concepts, models, to be able to apply the same concepts with the different problems. And this is what you were following with the new model code. So I think there is no big inconsistencies. We are going in the same way. And the second comment is we were doing that along our history. 40 years ago, we had a safety format different for different structural materials, steel, timber, and now we have only one. And the ideas were created in CEB, FIP, our group. So we need to continue in this direction, trying to cover in following this philosophy the existing structures. It is not an easy task, but it is not an impossible task. And we need to be humble. We need to really know that we need to have a global view, because if you go into the details, you don't solve problems. You solve only that problem, not problems.
Thank you, Carmen. Yes, you will be our last person to ask questions, and then the rest to answer.
Yeah, it seems that to go to a unified code is a normal trend, in the sense that when you progress, always try to integrate and simplify. In that case, that is the normal way. For me, the problem is methodological, how to go to this point, how to organize the work and the final chapters, but mainly it's time scale. And talking about the assessment, I see that we are just starting to have some models for deteriorated structures, but not agreed. And some of them have been not mature enough, just introduced into the present model code. In that case, for me, the main problem is to have good models for deteriorated or existing structures and have them agreed, confirm in practice that they work and they reflect reality. In that case, for me, the main problem is the time scale.
I think it's a very important problem, question that you raise, and we will really need to give it attention when we are discussing the specific fields of improvement, because we, in the end, want to fix the roadmap and the deadline. Hugo said having the deadlines is smart, but it's also necessary for us to manage the expectations from the users, what they will get and when they will get it. If you have the last, very last comments to that.
Yeah, I mean, I have a brief response to your point, which in a way, your question kind of gets to the essence of some of the problems that I've had over the years and the reason why I started thinking like this. And that's because if we take, for example, the issue of deteriorated structures, I simply don't know whether the models that we have apply to deteriorated structures or not. My feeling is that the ambition we should set ourselves is to look at those models that we have and say, are they applicable to deteriorated structures or not? Or what do we need to add into them so that they're applicable to deteriorated structures? Or is it simply the case that what we need to do with deteriorated structures is to put different parameters into the models that we have today? And if the issue is that we just need to plug different parameters into the models that we have today, then we can have a general model, which is applicable for structures in pristine condition or deteriorated. And then in the application for assessment section, then we give the guidance on what parameters would need to be measured or predicted for a deteriorated or deteriorating structure to feed into that general model. So that for me is kind of the dilemma. And then one of the advantages if we can take this kind of approach is that as new knowledge extends or new techniques evolve for examining the properties of deteriorated structures, then we can develop those techniques, provide better guidance to people on how to determine those parameters, but still retain the same core.
Thank you, Steve. The very last comment.
I fully agree, Carmen. The problem is, as you know, we've been working on some of those deterioration things for quite a long time. Ideally, yes, we would like, Stephen Hawking's approach, the unified theory of everything. Now we're a very long way from that, and obviously Steve's aspiration is great. We all will go for that, because if you have the unified theory, you could then achieve your simplifications. But unfortunately, we built it up largely the other way around. But maybe an important step forward is obviously to try and get some further progress on these issues. But if we can formulate our approach, our structure of our document, which will allow future revision, and we go from producing a book where it is completely revised to maybe having the facility to update certain equations, then maybe that enables it to have an ongoing life. But obviously that means that there's a different distribution format and a whole series of other issues. But maybe this is the sort of question that we need to sit down for a couple of days in the future, probably not too far in the future with the timescale, to establish how it'll work, how we can proceed.
The future begins today. So I think yesterday actually our future started yesterday. Thank you very much. I think we are now at the moment to start to, if I quote Steve, look at the models and see if and how they apply to existing structures. So Robbie, you will be our first speaker to take us into technical content. And I will hope you get this presentation.
Oh, yes.
Too much. No, he's saying he's a press. I think what he's saying is in the format still. But it sets a bigger point.
I'm against the imperialism.
Okay, thank you.
Well, I am very happy that the word safety format already was mentioned plenty of times. That makes my work easy. So my name is Robbie Caspera. I'm associated to University of Ghent, and I'm also chairing task group 3.1, which is related to risk and reliability of existing structures. And I want to give you a little bit my view about differences and possibilities for risk and reliability related items in existing structures. I also have a few thoughts about what we already heard about this general concept and then the detailed approaches. But I kept quiet because I knew I had a microphone, so I will squeeze it in the presentation because I appreciate the concept, and I have also a few thoughts because we tried to apply it for new structures, existing structures, and even temporary structures to come to a common sense or common methodology, and this works out. The question is how to deal with that, but I come back to that in a few seconds. Let me just give you a few these are what I always mention if I'm talking about existing structures. We're confronted with a little bit of duality in engineering, which I call it a duality between very detailed guidelines, very good guidelines for new structures, very detailed analysis of which you can ask whether this is really applicable for everyday engineers. We have all kinds of numerical testing and all kinds of analysis tools. But on the other hand, if we take a look at existing structures, we often get very vague guidelines and very vague rules with assessment schemes and so on. But if you really are looking for detailed calculation methods for existing structures, you often don't find very much information, or well, you find it within specialized literature. And then you get something like this, where you have a weak bridge, except for the buses up to 12 tons, and this is something which we then have to face. So we have to do something, but we have to recognize that although we try to aim at the general concept, that of course situation is a little bit different. So we already mentioned it, different structural models which might be applied. But also with respect to risk and safety related items, I think these three are very important. We have the ability to take additional measurements, although our measurements techniques also are uncertain. We have variabilities in our assessment. We also have to acknowledge that we might need a different safety level for existing structures because the economic considerations are completely different. And also we have to deal with remaining working lives, which are different from the typical periods which are mentioned for new structures. So how to deal with that and to make it, and this is the most important, although the philosophy is clear behind it, how to make it clear explicitly to the user. I think this is our most important task. And one of the other problems we have is to deal with all these uncertainties, because in assessing a structure, we have all kinds of uncertainties which are typically different from new structures. Or most of them are different from new structures. And as you know, and this is one of my favorite guys, Thomas Bayes is well, somebody who we could use to solve that problem, but there is no guidance for the moment to do that in our model course. So we need also to solve that, I think. Okay, what we tried to do in the previous work of the SAC 7 working group A2 was to come up with a proposal for partial factors for existing structures, which is dealing with these issues, but keeps in mind a few aspects. It should be coherent, it should be easy to use, because at a certain point you don't want to overwhelm practical engineers with too many detailed investigations, too many detailed theories. It should be straightforward, and then also very important what we had in mind for partial factors, compatible with the safety format and the framework which currently is accepted in Eurocode or in model code. So we shouldn't do something completely different for existing structures compared to new structures. This would be completely ridiculous. And we should take into account, this is the large, let's say, important aspect, we should take into account the things which make existing structures different. So alternative safety levels, alternative remaining working lives, alternative reference periods, and additional information which we could get, and how to do them. So we developed, well, we are now finalizing a bulletin with an editorial part, so we hope next year we can present this for approval, how to deal with that. I'm not going to focus too much on that. I'm going to show you a few results and try to couple it back to that system of a general framework and then a few detailed rules. If we take a look at target reliability levels, if we take a look at what currently is in the standard, this is quite easy. You get a target value. That's easy for practice. You have a value, and even more practical, you have already the partial factors, which are calibrated based on the target reliability level. So if we want to change that for existing structures, you need first to explain what the background is. So this is the general context. The general context is clear, it is available, it is accepted. So first you have to explain that, and then you derive towards the partial factor, which you then apply for existing structures. Now, one of the questions I have there, and this is coming back to the philosophy which we have, do we need actually to explain all the details first before we arrive at the target reliability levels, partial factors, which people should apply? I don't think so. I think this is a little bit too much. I think this is more like background information, because otherwise we're going to overwhelm. So it's not that the general framework is not available, but we should also avoid that if people have to jump in this kind of economic considerations and optimization and so on, they will lose themselves. So what we tried to do in our previous work is to fix that general concept. We will clearly communicate that, then work towards a proposal for existing structures, and this will be the same philosophy which is followed as if you would derive the new structure, the values for new structures. Basically, if we take a look at the safety level, what is different for existing structures? So basically, target safety levels based on economical and human safety arguments. If we take a look at economical arguments, it's clear that if we have a cost optimization for existing structures where we have increasing costs depending on the increase of this the reliability level that you aim for, that this cost associated to an increase in the reliability level is going to be steeper, which will be heavier in case of existing structures because of the interventions you have to undertake. So from a pure conceptual point of view, it's easy visible that you immediately will need another optimal target reliability level compared to new structures. So it's clear that you need something else. So just copying the value for new structures for existing structures will be a mistake. You need to take this other philosophy or this background into account and come up to certain values. So within this SAC7 work group, we derived a set of guidelines, a set of the methodology. We described the methodology, and at the end, we're also proposing, similarly as for the concept for new structures, we specify values to be used for existing structures, although it is a little bit more complex. Why? Because we have several assumptions. So here we have not one specified value, but we have a range. So we cannot come away with one table. We need a range of values. But in a certain way, we can also give some suggestions to that. And this, of course, becomes then very practical. We can end up again with a table, and the table is easy to use. So if we want to come up with suggestions for the model code, I think it's very important that we, at a certain point, come to code requirements that will then be these tables which we have to put in and which we can suggest to then be part of Eurocode. But at a certain time, we should give the background documentation, keeping in mind that not everybody is interested in the background documentation. So how to deal with that in the system that you propose, I'm not completely sure, although I like the concept. Of course, you need to have the general concept and then derive, which we did. But how to communicate that, I think, is a little bit difficult. So do you have to do that with background documents, with bulletins? Do you have to include everything in the model code? It's an open question. I don't know the answer for the moment. Let me give you a few other results, but I'm not going to spend too much time on that. So we tried to do the same philosophy for deriving partial factors. So the concept is clear. You can use the same concept, which is documented before, and you can apply it for new structures, existing structures, and even temporary structures, although this is currently out of the framework of today. So the concept is clear, and then you try to end up with values which are really practical to use. And in the sense of existing structures, because we have remaining working lives which are different, we have different information, we need to look to a framework which is easy to understand for practitioners. And what we came up with how the use these so-called nomograms, like I always call them, in which you have different values in the axis here and there, and then you end up with a certain partial factor. Of course, there are also equations for that, and there are derivations for these equations, but again, I'm not sure whether we have to communicate all of that in a model code. But we should add it in a background document or something. So here you see, for example, using a so-called design value method, we have a model uncertainty, we have a partial factor for the material. You select based on your assumption for the variability and the target reliability level. You have one of these curves, you have a point, and yes, you select the value of the partial factor, and you combine it with a value for the model uncertainty, again based on another formula. We have values for that in a table. You again select the beta, and you go to the partial factor. This is easy to use. You have two values which you select in a table, you multiply, and you have a value to use in practice. I think for practitioners this is enough, although the philosophy is very clear, can be communicated, and is the same for new structures. This is possible. We have that also for, well, just to inform you, this is for material, but we also did it for permanent actions, variable actions, for wind load, snow load, imposed load, traffic loads, all you want. And this will be available hopefully beginning next year for all of you to comment and to use. But we also recognize that we also could do something else, and this I also want to point out. If you want to do something which is really compatible with the Eurocode framework, you could also do the following. You use the gamma factor for new structures. This is a little bit a different philosophy. So then you take design for new structures as a basis, and then you adjust for existing structures. So this reflects a little bit another philosophy, not general concept to derivations. This is general concept design is standard philosophy, and then you adjust it for existing structures, something which you could also do. And theoretically, you can also derive here for these adjustment factors, you can derive values, taking into account reliability levels, uncertainty, and so on, specifically for existing structures. There you go to a second, also nomograms. So here you have an adjustment factor. If you have some updating of the coefficient of variation for concrete strength, for example, let's see here. Let's see that compared to the assumptions for new structures, you only have a coefficient of variation of 60% compared to new structures. You go into your graph, you select the appropriate graph corresponding to a certain reliability level, you have an adjustment factor, and you multiply the 0.87 with the 1.5 in Eurocode. Very practical. Again, I think this is sufficient for practitioners if they have a table like this. You don't need to know the derivation of this formula. Of course, it should be documented, but I don't know whether it's really necessary. It is really clearly, you can define it from a general theory, you can derive it, you come to this theory, but I don't know actually whether we should know or should put this really in the model code as a text manual. This is a little bit, I think, too much. Just to inform you, I showed you one example for material strength, but we also have it for action, actions and so on. Okay, enough as an example for this general framework and derivation for new and existing structures. So most important message, I think, is I like the philosophy. We applied it. General concepts, derivation new, derivation existing, should be compatible, logical, and so on. But at the same time, I think we should question ourselves where we should really report that general concept. For material models, I think that is easier. But safety format, I think you quite easily lose people with that. So there might be something in between. It might be that you have this system of general concepts with derivations and so on and adjustments for parts of the concept or parts of the model code. And that for parts of the model code, you don't do that because otherwise you are going to lose people and you put that in a background documentation or something like this. But I think we should clearly think about that. I think it's possible for a lot of aspects, but I don't know whether it's really preferable for a lot of aspects. Okay, some other aspects I think should be treated in the model codes 2020 or 2025, 2030, I don't know. We discussed about the last period, and also yesterday we still discussed about these. I just want to communicate a few aspects which we think currently are lacking and should be in a model code provision or which should be addressed in the model code if we're going to extend it towards existing structures. So one of the problems is you don't know what target reliability levels you should apply for existing buildings and existing structures. There's a lot of documentation, but we should condense that in a model code guideline. It's not that it's completely new. We have guidance for that. We should put it in the model code. We should give this guidance in the model code. What to do with monumental structures with respect to risk acceptance? Then this is where some of these concepts are ideas for further, let's say, development. Not all of them need to be in a model code, but maybe they should be slightly addressed. For example, we also should recognize there is an RQI concept for risk acceptance. I would say that we have to include all the details in the model code. I think we should just specify maybe a sentence, maybe a small paragraph to identify that there are other things to be or to look at, or which could be looked at. Risk-based decision making for optimal inspection intervals, etc., which is, I think, a topic which is together with one of the other task groups. Robustness assessment criteria. This is a long philosophy, I think. This would be really nice to have robustness assessment criteria where we could really do the verification. I'm not sure whether this is possible for the model code 2020, maybe for 25 or 2030, but 2020 is maybe a little bit soon. But that doesn't mean that we cannot mention it, that these robustness assessment criteria could be developed and to leave an opening to add it and to make people aware that such things are possible. We also already talked about sustainability, so how to deal with or to develop really sustainability requirements and how to look at the trade-off between sustainability and other requirements is something I think we should also take a look at and also comment on that on the new version of the model code. Maybe not with all the solutions, but at least we should try, I think, to identify a few important aspects there. What we also need for existing structures with respect to practical applications is to fix priors with respect to actions, priors with respect to material, in order to guide the people to use certain models and not to leave it just in the wild and just leave everything up to themselves. So we need to specify priors, and if they have additional information, we could update it. We should specify clearly how they do the updating. Of course, this is again not completely novel, these things exist, but we should give guidance in our model code how to do that in case of assessment of existing structures, in order to avoid that everybody does it on themselves. How to deal with proof loading, how to deal with visual inspection, these items I think are very important. And then the last one I think is also a very important one. I think we should give some guidance how you can make some reliability-based evaluation in terms of the type and the number of testing, because currently this is, I think, most of the time also completely random. I think we can do better. I think we can really specify, taking into account the accuracy of the measurements, some selection of a number and a type of laboratory testing and inspections. So I think there we should give some guidance to people in the model code. Then finally, also for the analysis, full and semi-probabilistic, just discussed here full, global safety formats for nonlinear finite element calculation in existing structures. I think this is also some aspect which we have to address. What model uncertainty should we take into account there, or can we make a proposal based on some investigations? And also specify and clearly indicate that there is a difference between model uncertainties between reality and the model, and otherwise model uncertainties which relate to go from the model to the results. I think this one is addressed very well, but the schematization and the errors there based on the schematization, I think this is addressed not so clearly, and we should maybe also give some guidance and some values there. And also, I think that model uncertainties with design empirical models for adjusted models or for new models for existing structures, there we should also give proposals for model uncertainties which are based on statistical and or reliability-based assessment. Okay, this being said, I'm at the end of the presentation.
Thank you very much, Robbie. Just for your information, I can understand this is it's probably very difficult to give it attention to every item. All the presentations will be make available to everyone who would like to have them, also to the members of the TC, just to provide them with the input. As far as the discussion, again, we ask Aurelio Mutoni to reflect on this topic from the point of view of Commission 2, which has similar field of interest. I suggest we first hear this comment, and then we will ask again both of you to discuss it with the rest of the audience.
Thank you. Welcome. My name is Aurelio Mutoni. I'm a professor for concrete structures and bridge design at the École Polytechnique Fédérale de Lausanne, and also part-time, and also a consulting engineer since some years. I'm also member of FIB Commission 2. Commission 2 met some weeks ago, but we didn't have enough time in order to discuss all these topics, and which means that my presentation will be a personal view, of course. Well, this is probably one of the most interesting buildings in this continent. Built 13 centuries ago as a mosque, and then 5 centuries ago converted to a Catholic church, and there were also a new cathedral inserted in the mosque. It is interesting to see that at that time when it was built, they reused some parts of a previous church built by the Visigoths, and even some parts from a Roman temple. What does it mean? Builders and engineers are dealing since centuries with existing structure. This is very important. And the second lesson is that in many cases, when we have to look at this kind of buildings, it is very difficult to distinguish between new and existing. This is a sentence we can read, and I heard yesterday, for instance. There exists a fundamental difference between the design of a new structure and the assessment of an existing structure, existing structures. Well, if we look at new structures or existing structures, and the point of view should be the point of view of the engineer, which means that when we talk about new structure, we are talking about future structures, in fact. Is it possible to separate these two kind of structure? I'm not sure, because in many occasions we have new structure members as part of existing structures. And when we talk about retrofitting, for instance, there are per definition in many cases new structures as part of existing structures. And it is also important to say that the overlap region here is very important for the engineering activity. It's probably the most important part. This means that it's very difficult to distinguish between new structures and existing structures. Of course, there are differences between design of new structure and assessment of an existing structure. We have different level of knowledge, for instance, about the structure. the assumption done for during design can be verified more or less easily. In some cases, it is very easy to verify the assumption. In other cases, it is it's very difficult. When we talk about design, we have required values. When we talk about assessment, we talk about measured values. This is perhaps the main difference. For assessment of an existing structure, ULS is more important than SLS. Because when we are assessing an existing structure, it's very easy to check if the required, if the structure works correctly or not, provided that the actions remain unchanged, of course. And then there is another big difference, of course, is the different economic impact of a requirement if a requirement is not fulfilled. We're talking about cost of retrofitting, of course. And then another issue is deterioration. We'll talk about this later. Another difference we have between new and design existing structures is what we have to do when we have nonlinearity of the behavior. And in many cases, we have nonlinearity because of cracking and yielding of reinforcement. When we are designing, the approach, in fact, it is very much inspired by the lower bound theory of limit analysis. Assuming, of course, that we have sufficient deformation capacity. Because we, even if we calculate using a linear method, we assume this behavior here, but we check sections with these strengths here. And both are completely incompatible, which means that we have to be based on this lower bound theory. When we work for assessing an existing structure, the approach is, in fact, is a little bit different. And in this case, provided that with sufficient information capacity, the method should be more inspired by upper bound theorem or of limit analysis or nonlinear analysis. And this is quite an important difference. For instance, when we talk about Strass-and-Tide models, Strass-and-Tide model, in fact, they are based on the lower bound methods of limit analysis, which means that it is very easy. They are very useful for designing structure. But as soon as we have the design structures and we want to calculate the strengths, then the approach has to be adapted. Of course, we can use Strass-and-Tide models, but we need additional. We need something additional which is related to strengths and mechanism. And this is also very important. The approach can be different. This is something also I heard yesterday. For assessment of existing structure, we need more refined method, correct. Only for assessment? This is a very simple structure. If I want to design this structure, I should be able to do it in some minutes. This is a structure we designed some years ago with a similar thickness, but with span. This is a shell, concrete shell, spans of 50 and 90 meters. We spent months on calculating this structure here. And we had a lot of problems related to stability, because buckling, shell buckling is the governing failure mode of this shell. And also, in order to get the correct internal forces, it was not an easy task, I can tell you. And this is to me, this is one very important problem we have now with current codes. They're usually rather complex for preliminary design or for design of simple members. but not sufficiently detailed for complex structures or for assessment of existing critical, this is very important, existing critical structures. And this is, to me, this is very important. We are talking about level of refinement of our calculations, of our approaches. I think the difference is not only between new structures and existing structures. We have other differences. For instance, the type of structures, as we saw, small or very simple structures, important, large, or technically complex structures. The phase of design is also, or the phase of design or the phase of assessment is also very important. I mean, if I'm doing preliminary design or a preliminary assessment, I should be able to do it with very simple calculations. If I am doing detailed design or detailed assessment, then I need perhaps very refined method. Also, the importance of the check, the critical, or if we have a critical or non-critical limit state, is also very important. If the limit state is not critical, why should I spend a lot of time in checking it? And to me, this is very important, not also for assessment, but also for design, of course. These are some considerations related to the refinement of analysis and the time devoted to design and or assessment. They should be related to the type of structure, of course, phase of design, importance of check, as we have seen, the consequences of failure or other required performances, of course, this is something additional, potential saving that can be provided in case of design, or the cost of integration in case of non-compliance with the required nominal performances. These are very similar, in fact. These are very similar, in fact, which means that what we are always talking about is only one part of the problem. We only speak about this part here, but here we have exactly the same, in fact. How to deal with very different problems in a consistent manner. Albert Einstein always said, everything should be made as simple as possible, but not simple. I like very much this sentence. I like very much. This is, in fact, this is what we have proposed in the model code. The idea of the levels of approximation approach is very simple. We should start with a very simple calculation, with a very simple model, and only if it is needed, we should improve the precision of the calculation. And this is very important, this process should be incremental, which means that we should not repeat the whole calculation. We should only improve the parameters which are important, which are relevant. Only the parameters which are relevant have to be improved for the next step. And to me, this is very important. So this is a question, and as you can see, this is in the same time also a proposal. Should we have level of approximation also for safety format? And do we need different safety formats, or do we need one safety format with different level of approximation? Robbie, this is you can recognize a text taken from your publication 2 years ago. Very excellent publication. This is very nice publication. You were dealing on what you have shown some minutes ago, the approach for existing structures, right? And you wrote The safety format should be able to account for a reduced reference period, which should be preferably related to design working life. Fully agree, but we should be able to do exactly the same for this kind of problems. This is a new structure, and we should be able to do exactly the same. And this is very relevant. And this is what we do in reality. This phase, this governing phase here, this is governing for the column here. The duration is only some weeks or some months. We should take into account an adjusted reliability level, target reliability level in beta, and having in consideration of the changed economic and human safety consideration of existing structures. Why only existing structures? Adjusted probabilistic models for basic variables, for example, for modifying their coefficient of variation. Correct. But for instance, in this particular case, very detailed wind measurements have been performed years before the construction, which means that we know very, very well the loads, and we are also able to do this work for a new structure. My proposal is that we try to work on a very general safety format, to simplify it for different levels of approximation, up to the simplest safety format, which can be used for very simple calculations. And then in the engineering work, that we refine it, but only the relevant parameters. And this is why I like very much the partial safety format. We should be able to refine only the parameters, only the safety factors which are relevant. It is not necessary to adjust all the safety formats. And to me, this is very promising. Oh, sorry. Model code already contains very valuable information for this purpose. We have just to simplify, and we have a very interesting work which already exists. Now, this is, I'm trying to summarize. These are the needs for advancement. The first one is the level of approximation for the safety format for new structures and for the assessment of structures. Another problem we have, this is a very important problem, is what we do with nonlinear calculations. This is very important. More and more we perform nonlinear calculation, not only for assessing existing structures, but also for designing complex structures. More and more, in fact. What we do, for instance, in my laboratory and with my students and in my company, we use nonlinear calculation. And as I say, and for the safety format, we use the partial safety factor approach. I don't know if it is correct or not. We have to prove it. We have to work on it. And probably we have to adjust some parameters. We have to work on the model uncertainties, of course. This is a very important task. But this is very important for the next years. Another problem I see is that we have to work on the reliability of the calculated internal forces in redundant structures. This is very important, and I think this work is needed. If we have a ductile behavior, it is not very important. But if we have a brittle behavior, redundancy is a problem. If we have the ductile behavior, redundancy is a big advantage. But if we have a brittle behavior, it is a problem. And I think we have to work on it. And this is, of course, very related to what Giuseppe mentioned about some in the last discussion we had. Another problem I see, which is very relevant for us, is the soil structure interaction. Many structures, many concrete structures are in contact with soil. This is a big problem we have, in fact. Let's assume we have this cut and carton. And this is taken from the guidelines we wrote some years ago for our federal administration, road administration. Let's assume we have this cut and carton tunnel. If it is very well designed, if the shape is very well chosen, then we have no bending moments. But if we assume that the soil is not completely symmetric, if the level of the soil is not completely symmetric, for instance, then we have bending moments, which means that we have to take it into account. And here again, this works in favor of the partial safety factor approach, also for nonlinear calculation, in my opinion. So we have to work on it, in my opinion, because this is very relevant for practice. So this is my last slide. To me, this is the first priority. We have to. It would be very nice if we could have a level of approximation approach for the chosen safety format. Most of the work has been done. We need to have a consistent treatment for design and for assessment. We need to have a consistent treatment also for nonlinear calculations. And we don't need, in my opinion, this is our personal opinion, we don't need two different safety formats for codes or codes for design and assessment. Thank you for your attention.
Alrighty, thank you very much. This is exactly what we needed. We need a discussion on issues that we are going to work on. Robbie, I will ask you to come forward. I think you will be the first one to react to what we just heard, and then both of you, I will ask you to answer the questions if there will be any. And what I have heard is the common agreement that we need sound and consistent formulations based on concepts that are general, correct, and then probably can be applied both for new or future or existing structures. But let's go down to the technical questions.
Okay, I'm starting to think that this will be a very easy workshop because we start to agree on everything. That is good. No, I very much like this idea of several levels of approximation. So in this bulletin which we are preparing, which I comment on a little bit, we are also doing this a little bit, but not maybe so structured as here. But we also have there, let's say, more refined analysis where we really work with probabilistic models, and then you make it a little bit simpler by using this design value method, like we call it. Then you can even make it a little bit more simpler, and then you have this level of adjusted partial factors. So we're doing a little bit the same, maybe not exactly in the same format, but I really believe in this principle because at the end, level 4 is a general one. So I think we completely agree. Because the principles are completely the same. So if I go back here a few slides. So actually here, you mentioned there why only for existing structures. Indeed, it's not only for existing structures. The philosophy is the same. So basically, it's the same for new structures, existing structures, and like I said, you could even do it for temporary structures. So philosophy is the same. We can communicate that. You can apply it, and so you have a tool to make adjustments with reference periods and reliability level and so on. Which is, I think, the basic problem today is that it's not clearly communicated, and nobody knows exactly how to do it. Although it's within several people have consensus that this is really the way to go. So it's more or less clear, but it's not clearly communicated. So if we feel that this is really a necessity to communicate this general philosophy as a relevant item for new existing structures and contemporary ones, then I think we should do that, and we can add that in provision. So that's I think we can agree on that. A little bit, well, the third item there with reliability of calculated internal forces and redundant structures, I also think this is very relevant. We didn't take up that work in our group yet, but as I understand, Commission 2 is to also investigate that system behavior, and this is more related to do with system system reliability, let's call it like that, or risk acceptance as a system. I think this is very important, and I completely agree that this should be also an important item. Although it's not easy, and it's also definitely not easy to generalize. The advantage of this partial factor method and the way we addressed it is that it is a very general theory which you can easily calibrate, making some basic assumptions, which also have been made for new structures, for the development of these rules for new structures. That's very global. In case of a system level, I think it's more difficult to come up with a very globally valid system with partial factors and so on. How to deal with that is not very clear, but we should maybe think about that. Whether this will already be again in the Model Code 2020, this maybe 2030, but at least we should think about it. And I also think we should clearly identify that in the next level of Model Code, because most of the people do not acknowledge that we are on an element level doing most of the time these verifications. So we should clearly identify that there are also the system level that they should take into account. I think also this is very important. Minor last item is with respect to nonlinear calculations. Partial factors nonlinear calculations, I'm not completely convinced yet whether this really is the good way to go. But also there we have a difficult item, because it's also difficult to generalize that. This is the basic problem. It's depending on which case you are looking at to see what performance it gives to use either a global safety format or a partial safety format. Again, there I don't have solutions now, but I think it's also good to investigate it a little bit further. And anyway, give some guidance to people, or at least if we cannot able to, if we are not able to give guidance, give some warning to people in a Model Code. That's my comments.
Questions?
Yeah, but I have a remark on the last sentence. I agree with Robbie about this aspect, the last one that you consider, that is we need a global safety factor on the nonlinear analysis, in my opinion. But the last sentence that you presented, no need for two different safety formats. I think that in principle is necessary some differentiation, because we have to treat the epistemic uncertainties. We have no epistemic uncertainties in the new structures, because we conceive the structure in some way. When we have a connection between two walls, we detail the reinforcement for the shear, for the bend, But we don't know what is the reality in the existing structures. This is one of the examples. Then, or we are able to catalog the uncertainties, possible epistemic uncertainties in reinforced concrete structures, and to transfer in PDF, to describe with PDF open or closed distribution, or we have to use a Bayesian approach or engineering judgment and to combine both. But I don't know how we can overcome this particularity of existing structures.
Engineering judgment is always needed.
Exactly. Yeah.
Exactly. Per definition.
But that means that we differentiate.
I'm not. Are you sure? I'm not sure.
Yes.
I'm not
because
sure.
you have to assign a probability. When you have the nodes.
We're talking about the format, not the method.
But you have in some way to take into account the judgment of engineer and the probability to assign a probability to the judgment of
and for and when you're designing, it's very similar in fact.
But I agree with the fact that this is a particularity for existing structures, but I don't think that this is a problem for the format, because if you think about variations of properties, you can take that into account in the model. If we take into account the level of model uncertainties, we can adjust the model uncertainty coefficient to that. So we could add there manipulation factor to overcome this. And so I think that basically we can end up maybe with the same basic formulas and then have some adjustment to the formulas. But I think this is what we also try to do in SAC 7. To come up with a set of formulas which are the general framework, and then you can play around with a few parameters like you want, or like you in your situation are relevant. With respect to updating, this is also something which we, I think, further have to address, but this immediately is applicable to that, for example, the adjusted part of the method and also the design parameter, you can immediately adjust it there. But the way how to do it, based on existing structures, this is something which has to be explained explicitly for existing structures. So this would be then an item which is on the additional rules, where we have to specify, okay, you have now data. Now, how are you going to do the updating? This is something which is then particularly there, but maybe the general framework.
Giuseppe, I fully agree with you. The parameter can be different, or they are different. I fully agree, and we have to define how to calculate them in the case of an existing structure. But the format can be the same, in my opinion.
Yeah, or to invite the designer to make, in such cases, sensitivity analysis.
For instance, yes.
And then to combine the result. But in any case, you have to add something to combine some sort of probability.
Yes. Right. Yes.
So
Fully agree. Fully agree.
Yes, I would like to join this discussion because, as you well know, we have come, I think, during the preparation of the model code 2010, we expanded the safety format for the global safety format, which was mainly introduced for the purpose of global analysis by means of nonlinear finite elements. So I think that was important that we have done already. And I think the interesting on this concept was that it was based on the global probabilistic concept introduced by Joint Committee on Structural Safety. So we actually tried to put it in the framework of existing probabilistic concepts. So that was, I think, a good start. And now we are facing the problem how to keep the line along the probabilistic concept when we are applying it in practical calculations. And we proposed, for example, we are in favor of using partial safety factors when talking about global safety format, because this is the nice starting point. And according to my opinion, it is a point estimate based on probabilistic considerations. So we have now, of course, a number of contributions, number of new publications which are extending this knowledge, and some of them are using different point estimates of our design point, and we have come with Eckhoff method and so on. So all these things are available, not yet fully validated, but I think can be nicely extended and improved, and at the same time we can keep nicely the concept which we started to introduce. So I think this is good start. And one of the major disturbing point is model uncertainty.
Yes, correct.
And we have to work on that. And we have there are many publications today appearing which are improving this. And I think it is a good start.
Yes, I think this is important. We have to modify. I think we have to adjust some parameters in the approach, of course, and this is the main point in model uncertainty.
Yeah, what is very important is to realize that we are spending a lot of time to calculate precisely the safety based on material uncertainty, while at the same time we have their model uncertainty, which is much higher actually. So that is a bit correct. And I think there are ways how to handle it.
Thank you. Thank you, Vladimir. Rafael?
Yes, thank you, Professor Montoni, for your presentation. I'm in favor of many things that you mentioned. It's also nice to have this safety format not only for existing structures but also for temporary structures and new structures. I think the basic concepts are the same, and I think because we are trying to develop this system, we should closely connect our work to the work of the Joint Committee on Structural Safety, because it's a very general concept that can be applied not only for concrete structures but also for other structures. And I think we can learn from interaction with the Joint Committee on these subjects. And then a second remark, we had the past few minutes discussion about partial safety factors, global safety factors, but I think these factors have been derived 20 years ago in a time where no computers were available, and now we have very fast working computers. So I think there can be made an effort to go to the higher ranked reliability methods. I think they can be easily made accessible, maybe not for every engineer, but for engineers with some more experience in this. I think these higher ranked methods can be made easily accessible because we have nice software programs working together with finite element programs. So I think there we can also make an effort, because still the simple safety formats have inherently conservatisms in them, and why we are switching to the more accurate but also more time-consuming methods, especially for existing structures, they might be of great importance. So I think there in our model code we can maybe also make an effort to make them more accessible for engineers in practice.
Yes, thank you for the remark. I fully agree with you. More and more people will work on this level here because it is easy to work on it and because there are tools which allow. But in the same time, more and more it is necessary to check this work. I'm spending a lot of time in my office in order to checking with very simple method the work done by my young colleagues. And for this purpose, I have young colleagues who prefer to design a new structure using nonlinear finite element calculations, for instance, and they are very fast. But it is very important that there are experienced people like me that they can check it very, very quickly and very fast. And for this purpose, I think we need both. We need very refined method for performing this kind of calculation, but we also need more and more very simplified method in order to check this calculation.
Robbie, I don't know if there are any questions still coming from the audience. I will.
It's a very small comment.
Yeah, Konrad, and I will have one which I will ask already now, but then keep it as the last one, because this will be a very difficult. What can we reach in the time that we want to spend on the first draft work process? You mentioned a lot of issues yourself where you had doubts whether it can be reached within 4 years, 5 years. Rafael added a few others. Some others came from Professor Montoni. We will have to give it some thinking, maybe not necessary today, and define the scope that is feasible for the roadmap that we intend to deliver. But first, your question.
I do have only two remarks. The first is related a little bit to the general safety format. I really agree on that. We should include the consequences of failure, that means the probability of failure. So this important issue must be included also in our design process, since we are using it explicitly. Second issue is related to the soil structure interaction, which is a very, very important issue. specifically also coming into the time-dependent behavior of the soil. And this is a similar issue as it is the degradation or the upgrading of a structure. So that the soil can get stiffer or weaker. And this interaction is not covered yet. And so we should really develop some ideas how to deal with this issue, explicitly also with taking into account nonlinear analysis and what is going on there, keeping a certain safety format.
Okay. Okay. Well, the last comments I completely agree. With respect to your question, so these 4 levels of approximation, I think this is feasible for Model Code 2020. So we have basically the information.
Perhaps 3 are enough. Perhaps 3 are enough. I don't know.
Well, yeah. Well, we can discuss about about a number of, but well, actually, well, there's one level which we didn't discuss about, but which was now a little bit tricky, which was also you go towards a level where you actually perform cost optimization, and then you include actually consequence costs and so. This could be our level 4. Maybe there we don't have all information yet to do it. We have the principles, but actually to make it workable, maybe there we need some more information, but about that I'm not sure. But to come to a level, so with respect to a simplified level with partial factors, I think we have basic information which is available now. With respect to a more full probabilistic, updating based approach where we adjust partial factors based on the updating information. I think this is also feasible. This would be level 2. Level 3 where we actually work with probabilistic methods and we choose our priors and update them based on some information. I think this is also feasible because we have most of the models ready. We could have, I think, a first workable methods there, which might be over time be adjusted, but this is like, of course, our other methods in Model Code. I think these 3 levels are, I think, feasible in 2020. The items which are not, I think, really easy to implement in 2020 version, if we aim for that year, that would be items like robustness assessment criteria, sustainability criteria, these kinds of items. I think there we have a lot of work to do. Could be, but maybe not completely ready yet. At least I think we should mention and we should clarify and we should clearly indicate to people that these items are important. Similar also with the risk philosophy and the system reliability, we should at least explain that these items are there. Maybe not the entire methodology and the specific tool how to do every step. Maybe that is not ready yet, but at least we can mention this, I think.
Highlight another comment perhaps regarding to the first level for the safety format. For instance, the factors we have now in our codes they have been decided, not calculated, they have been decided at the end of the 50s, in the beginning of the 60s. I think now that we now know a little bit more about it. And we should be able perhaps to do this work here. And in order to calculate the needed safety factors on the basis of this work here, and not just from an intuitive point of view, or just based on very, 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 very simple considerations they did at that time.
The very last question before we
Yeah,
take a break.
Just, I wanted to put something that Stuart mentioned and deciding action, because that's something that we have to discuss at some point, whether we want to have it or we don't want to have it. And it brings some complications in general framework that we have. Okay, now in your code part 3, we are going to be changing that. The framework that is there, but we are talking there about, I mean, if you're talking about the last one of the structure, immediately you affect what is the action that we're using. So that's one complication that comes into play, apart from the other problems that we have. Therefore, we need different models for the materials that we are going to have. Maybe if we're talking about nonlinear analysis in that part, then we're talking about activity. And this is what we're checking. Instead of strength, we're checking displacements and we're checking on capacities and things like that. And my question is whether this framework that you're proposing can capture these things, because at some point you have to do that, in my opinion, because if you're in an area that you're going to have earthquake, then you're not going to start from the static load and then go to the earthquake. You're just going to start from the beginning, going to the actions that are going to affect your structure. You're going to consider, of course, static load, but if you're going to do strengthening, and then comes the question of economics, and then you have performance levels there. And based on the performance level, which means how much money you're going to be putting the structure. Important structure, then you put something else. If not, then you're going to do it with a minimum so that the private person, not the structures that you can affect like bridges and everything else, but on a private building that you're going to do that. And then the complication comes if you have multiple owners and what you're going to do that. And all of these problems are in there. And therefore, for general framework, if we want to have something as such, then concrete structures are always built, also built in areas that are earthquake prone. So we have to consider that. So that's my statement.
I think this is actually a point where we have to go to. We're currently in our, well, what we did in the previous work of the SAC7 group, working group A2, we didn't focus on seismic actions. It is the intention in the new tasks of this group, task group 3.1, to also take this with us. But for the moment, the partial factors, this is not straightforward to apply. But with respect to, like, for example, target reliability level, the principles are the same. So in this sense, I think this can be extended and so on. I just had one minor addition to, so I agree that this is something we should take up. I have just one additional comment and a little bit of warning also. I think we should also keep in mind that what we are proposing, so we are of course trying to develop well, a very good document which provides solutions for as much as possible as we can think of. But I think we should also keep aware that at first instance, the first idea, I think we should be able to cover very simple cases already. Because also there is a large scatter of what people are doing. So let's start with the simple elements and there have agreement. And then we try to extend it to more complex systems and so on and so on. So I think we should not wait to advance towards assessment of existing structure because we cannot solve the really complex problems. We already propose what we already can, for example, with these simple partial factors which are applicable to elements and under certain boundary conditions, which we are very valuable for a lot of cases, a large amount of the problems in assessment. So I think this is very important to keep it in mind that we advance already for a lot of problems which are occurring, or with a lot of assessment problems, let's say, and that we try to come up with solutions for the more difficult parts. And maybe this is not ready in 1 or 2 years or 3 years or whatever, but we start developing that and let's see where we get. And if we can include already detailed guidelines in 2020, let's do it. If we cannot, let's give guidance or let's give comments or warnings or whatever. Whatever we know by the time. I think that's what we are doing already now and where we are agreeing on, because a lot of things we are currently agreeing on, I think this could fit in a code. And so this is my observation.
Thank you, Robbie, and maybe this last comment?
Just short comment.
Very short.
Very short. I think that in the moment in which we are orienting the codes to design also for extreme events, like, I don't know, floods or detonation or explosion, terrorist attack and so on, seismic design is one of the cases, is an extreme event. There is no reason to continue to have separate codes for the seismic design. The seismic motion is an action. then we have to consider the level 2 actions, and then the design should be consistent for the different extreme events. In my opinion, I will be killed when I go out from this room, but the future is that. There is no reason to separate this kind of action.
Thank you very much. And maybe this comment or the last comment from Robbie before I ask you questions, and I would invite you to have a coffee and discuss it over the coffee. We will see each other again in 15 minutes.
Very good.
Thank you. You see how much fun there is in the coffee. More pages in the book. No. Not physical. Not physically. More. Yeah. I have no idea of checking. As soon as we have something general. Yeah. And then it's not necessary anymore to put additional. This is the problem. Yes, exactly. We're a long way from yes, of course. Go on, Robbie. Yes. Yes, of course.
You use also the for the robustness. You may use at the same level.
They are based on the global different than
the global behavior of the
section 4, then on the levels, it's 0.6 times FC.
And the ones I was going to say that because I think that approach of having different levels of automation is absolutely using a simpler model, it always gives you a more cautious result.
Yes, exactly.
Because that's the point. Yes, problem with your case at the moment. Models that give you a better, a more economic outcome. My presentation is kind of short, but so many of the points
Yes,
exactly the same book.
yes, yes,
Exactly
yes,
the same
yes.
book. It was very interesting. Even the throwaway line, when I said the problem you have with designs and assessments is that you have emissions. It was another point that you made, it was very interesting, very similar to what
You're sure of that?
yeah, maybe we're both wrong. Or both wrong, both wrong. Yeah. But I think the challenge with that approach, both really is that the first thing is that so this is but then I don't think we look to achieve people, then what we actually need to go
Yeah. I want to make it things. We should extract.
Yeah. Exhausted at the end of the day, but when you sit there, you can just sometimes you can just pass away the problem.
It's that I bought a map of what's I only want to see what matters to me is not not worry about one wrong. So if the point existing tries to think the pieces, reassemble it in a more simple way, and put it on the level of the system. The thing is that we have so it means what is the but this is based on a huge difference. In the same of dilemmas for reasons, they think that it is structural, and then you can select the entities what we otherwise I had a good example in my office. 70 people there, multiple and price choice. There's only one product that was used in the past 2 years. And they had to use it to know the see what was going on. They never did it on some reason or something. It's an issue. And then you are paying. And then the pay. Not from the perspective of the user. That's the point. That's the point.
Ja. Kost het niet. Zal ik gewoon de vrienden zijn? Nou, dan volgen ze maar af of het niet wat warm wordt.
Maar als je in de gangen loopt en alles, dan is het niet te doen. Ik heb hem ook warmer gezet bij mij. Echt? Ja, het was gewoon koud.
Hij stond op -3, ik heb op -1,5 gezet. Voor mij is het wel ook hoor. Echt
Ja, hoeveel het dan werkelijk is, weet niemand.
Nee, dat weet niemand, nee.
Via je telefoon, weet je dat? Temperatuur. Dan zie je niet meer voelen, maar je voelt het hartstikke koud. 23 graden is het hier. Oh, die heb je. Hè? 23 graden, dat is t-shirt weer hoor. Dus het zegt die thermometer. Dat is wel hoor. Ja.
Nou, voor de rest gaat het allemaal lekker, hè?
Nou, in het begin had je de radio zetten op 3 uur geloof ik. Maar ze zaten hiernaast. Ik weet niet.
Daar was hij naast. Nee, het ding is, je kan de zalen kan je koppelen. En daar is even wat mis mee gegaan.
Dit is een wacht of niet, hè? Wat dat betreft.
Ja.
Ja.
Oh, 5 passes. Okay. Let's go in the right direction then. I think that the presentation of Aurelio was a good basis for some of the results. So we don't need different approaches for design assessment. We need more levels.
Arbitrary that this method could be used also for existing factors.
Yes.
They was not proposed
Yeah.
already.
Yeah.
Okay, because my feeling was so much things.
Yeah,
So
it's very elaborated what they propose. This is your first one. This is from Joost.
Yeah.
This is name number 6. And the next one is number 7. This is in comments to it.
we have only two.
Do presentations because Brad will say
Yes,
nothing,
and,
maybe in discussion, but they have two presentations, but they are long, relatively long.
Okay, okay,
And
so
so you have like half an hour for yours, more or less. Maybe 20 minutes. I put 20 minutes because we are kind of behind the schedule.
Yeah.
But we have presentation. So
also both in the
yeah, no, that will be in the afternoon, but Jose is not coming.
okay.
So this one is not here. So Brad is not here. I mean, Brad is here, but he's not presenting. So I thought we will start by 45. Yes, I think we can start now.
Yeah.
They can take coffee with them. 45, 10 minutes behind us. How much minutes? Let's say I have yours should be 20, Aurelio 20, and then half an hour discussion. 1 hour. Yes.
We have 1 hour and 20 minutes.
Yes, we can do 5 minutes
Yes.
more. Yeah, until 12 o'clock, yes. Then it will be, yes. The only problem with this presentation is that you have to close it before you open the next one. Otherwise, And the mouse tends to move out of the screen.
Okay.
So you have to go back.
Okay, and close. And close.
Close again, and then you open the ticket 7, and then it works. Because if two of them are open at the same time, then there is a kind of problem. But this is yours. This mouse you just.
Yes, is that because the video is different
Yes,
because
exactly. So I lost it a few times.
and that is work.
This works. This is forward, backward, and the pointer.
Would you prefer to sit here? You don't like warm weather. Air conditioners.
Szerintem napokban ugye tehát jelen pillanatban szerintem azt mondom, hogy elég filigrán szerkezetnek kell, akiket ez ugyanaz, így van, jó, oké, igen. Tehát jegyzőkönyvet adjunk ki, csak hogy ez így megfelelően szoktuk így van.
Igen, hogy kiadták, tehát olyan, amikor dolgozás, illetve a kivitelezésének. És láttunk például a honlapszítésnek, tehát hogy kapcsolatok helyeztését teljesült, amelyek felülvizsgálatáról és pótlásáról fognak. Amit most működik, egyébként a túlfordulón, amit azt mutat, egyébként tudtátok folytatni a tanulókat? Ezt én is érzem. Bokogva ez beszéltük, de nem konszenzus, hogy ezt a szerintem is meg kell beszélni, legalább egységes.
Oké.
Ja. Denk je dat dit goed voorbereid wordt?
Nee, die andere die hiernaast gaat hem ook aan.
Ja?
Problemas tipo unitarios.
Sono stato forse un po' troppo provocatorio. Non le neanche. No, ho cercato di esagerare un po'.
No,
ma è un
dobbiamo arrivare.
tema che mi interessa.
Assolutamente, senza bisogno la resistenza media e coloro che venivano fuori lo verificavano con le azioni. Collezione di esercizio di essere motorizzati.
We can start this section. Before starting an announcement, if somebody has to enter boarding passes, could ask. Already done, so we can. Okay. Could ask the assistant. Okay. And we start with this section. We have on models and material characterization for existing structure. We'll have only two presentations from Jos Valraven and from Aurelio. And the presentation from Better will be together, will be in the afternoon. So, please, Jos, presentation. Thank you.
Yes, we had a very interesting discussion this morning, and one of the discussion points was how far can we use the existing model code already for existing structures. We have models with various levels, and the idea, as I said already, was that also advanced levels should be available in order to check structures for which you have to make important decisions. Are we going to upgrade them or not? And a lot of money is involved. And now we have some short period of experience, and we can see if this is really true. If we have models which are totally unsuitable, or if we have models that can be a little bit improved, so that they are generally valid. And well, let's have a look with some experience. So at first here to see the task groups, the general task group who have to think about the concept, and I think it's a very interesting task if I consider already the discussions of this morning. We have the working group on reliability and safety. We have our working group of modeling of structural performance of existing structures, and then two other working groups who will also report. Most of the elements, most of the aspects are comprised in this diagram, where we see at the vertical axis the resistance of the structure, and here we see the time, and here we see a structure which is designed, and as normal, the quality is not increasing, but it is going down. That's our general assumption, and we can have bad luck, because if the loads on the structure are going up, then we have, at a certain moment, we have a problem. And the question is here, when do we define to have a problem? And that's also a matter of the first task group. What we have seen in a number of cases, and this is the experience that we had in the Netherlands for the last years, that the structure are sometimes much stronger than they are expected on the basis of the original design. And that's because the original design was always a simplified representation of reality, and a number of things have not been regarded. One simple thing is the increase of the concrete strength, for instance. And our group has the task to define by assessment the strengths of a structure, and if possible see if we can use models or improve models to show that it is more accurately or better. And on the other hand, if you make an assessment, you do not do that for this time only, but you could also look to the state of the structure and look how it is expected to degenerate in the future, and how long it will last until the end of service life is reached, because the structural safety is not in agreement with the demands anymore. So we have analytical methods, numerical methods available, but we have also, for instance, the possibility to test the structure by proof loading. So we have to check strength and ductility of the materials involved, dimensional properties of the structure, the presence of defects, types of damage, interpretation of damage phenomena like cracking patterns. And we have to look to the future condition, and that means the determination of the development of the bearing resistance in time on the basis of observations and analysis, and the determination of maintenance and who is doing that. But a number of things we have to take into account if we make a prognosis of the future development, like the effect of fatigue, and especially the effect of fatigue in combination with eventual corrosion, the prognosis of the effect of ongoing chloride contamination, carbonation, or alkali silica reaction. And here we might wonder, how good are our models at this moment? Can we keep them, or do we have to modify them? And the prognosis of eventual reduction of robustness of the structure. Robustness is also something which has been discussed for many years, but it is very difficult to get it into a code. You have to describe it, you can make it very complicated. But on the other hand, you need also engineering feeling to see if the structure is robust or not. You can make big calculations, but you can often directly see this structure is not robust. So therefore it has always been very difficult to write a recommendation on robustness. Well, if we judge an existing structure, a number of things have to be regarded, like the loss of bearing resistance due to material degradation, reduction of cross-sectional area due to corrosion, damage due to long-term use, like fatigue, errors in the original design, errors made during execution, so what we call the epistemic uncertainties. Residual capacity due to ignored favorable mechanical effects. That's, I think, an important aspect of such a code, that we have advanced models that we can use eventually to very accurately describe the condition and the resistance of a structure. So the question is, how suitable is the FIB Model Code 2010 for the assessment of existing structures? Because we have already some experience. And I just take a few examples out of this. And the first is the shear capacity of slabs. And if we think about this, this is very remarkable, because the formulas in codes, not only the model code, but also the EUR code and many other codes, they are based on tests on beams. And hundreds of tests have been reported in literature, and they have been evaluated statistically, and they give the formulas that we have in codes. And the funny thing is that these elements are forbidden in practice, because if you have a beam width at stirrups, it is not accepted. You must have stirrups, it's set somewhere else in the code. So our rules are based on illegal specimens. But there is something more important, and that is that we can expect that the redistribution capacity of a slab is much better than in the beam. If you have a weak spot in the beam, it can be the end of the surface life, the end of the capacity. And here, if you have honeycombing, well, the forces can go along. And in our country, it turned out that hundreds of bridges with solid slabs are available, and they did not meet the demands. And then you can say, if it is 10% more, 20% more, you can save many, many bridges. So the question is, how much can these formulas be increased, the capacity, without being unsafe? Well, in our country, we have done some tests and calculations, and the very conservative estimation is that it is at least 10%, the difference. But I think it is more. In our country, we have glacial rift aggregate, so we can say that the formulas which have been elaborated by statistics, they contain a lot of beams with limestone and so on. So we must be in the upper part. So there's another 10%, so it's 1.2, and then you save already many bridges. But in other countries like France, if we look to the V-min in the code, we find that most of the countries in Europe, they have the same value. A few carriages are going to 1.1 or 1.2, but in France they go to a factor 3. And they are not suicidals themselves, so they have really a lot of experience. So there must be more residual capacity. And also another aspect is that if we have loads near to the support, or we have combinations of load, because a large wheel load is not alone, because it is a part of a car, and we have more, maybe 2 or 4, and so on. And there we think that this formulation is too simple. That's been done at Delft and in Lausanne, in Aachen, and in Hamburg, I think. And there we have, I think, material to improve this. And this is very important because we speak about hundreds of structures which can be helped by a better formulation. So this is an interesting task to make, in this aspect, the formulations in the model code more suitable for existing structures. Another aspect is what we had found and what other people have found in their countries, that all the formulas have been derived for ripped steel. So all the tests have been taken into evaluation with ripped steel, but nearly all the old bridges have been made with plain steel. And if you look in literature, there is a very interesting discussion because the results are contrary. So they have, there is a famous article of Professor Leonard, who has done 4 tests, has 2 beams with ribs and 2 beams without ribs. And his intention was to show that it's very important to have ribs because it's much better
than with plain steel. And then he was surprised that the shear capacity of the elements with plain steel was 2 times as high as the other ones. And he was ignoring this. He said, nevertheless, his conclusion remains that ribbed steel is better. And in his next paper, he just does not speak about it anymore. There was a very interesting paper by Kani, it was in the 60s in the ACI journal, and they really were fighting against each other. And Kani said, well, Leonard is stupid. If you do tests to prove something, you should take the result and not ignore it afterwards. And he said, it shows that my theory is correct. And this was a fight for, in the early 60s. I really can advise you to read that, because those people, they don't like each other. And it was a family history, because there is a book from Mario Kani, which is the son of the famous Professor Kani. And he has done tests to prove that his father was correct. And he did a very interesting test. He said, if I do a test and I reduce the bond, then it should be better according to my father's theory. But this is not so easy, because the bond depends on the concrete strength. So if you change the concrete strength, the bond is changing, but the shear capacity also changes for other reasons. So he had a very intelligent solution. He said, well, I make a hole here, and there's a bar, and I take a beam with a certain strength, and I fill the hole with various strengths of concrete, from strong to weak. And the weakest one is just air, of course. And then he found that the bond strength, when it is increasing, the shear capacity is indeed decreasing. So we have, in the model code, we have expressions, and they are for ribbed steel. And we think we can improve it. And that means, well, very simply thinking, you can say, okay, this is our relation. There is a very smart factor here that, for instance, takes into account that if you have at the end of a slab, you have low moment and a shear force, then it is different if you have an intermediate support where you have the same shear force and another moment. So this is very smart. But you can imagine maybe there is a coefficient to a bond factor, for instance, to take that into account. But yesterday there was an interesting discussion with Yuquan and Aurelio, who said, well, don't keep away of this. It's not so simple. But this is a point where we have to give guidance, where we can extend this model, and we should extend this model. Another point where we can extend the model is in punching. And also here something remarkable can be observed, because we have in Eurocode, we have an empirical formula. And people are discussing if the 0.12 should not be 0.11 or something. But if we ignore something, is that basically all these tests are wrong. Because the idea is that you have around the column, you have a moment deflection line. And the idea is when you cut out, well, fictitiously, you make a round slab with a load, and that's really the punching capacity, and you can see what parameters have an influence. But the reality is that this circular part is a part of a very large slab. And that means that if we have loading here and the punching cone is starting to form, we have a movement in lateral direction, and there is a reaction there. So a good test should be carried out like this. And then you can say, well, don't make such a complication because the other one is conservative. And then we have the point, because it is conservative, that means that in our country 70 large bridges had to be repaired and strengthened because the punching capacity is not enough. Therefore, this has been done. The tests have shown that if you do large tests, the bearing capacity is much larger, where we had insufficient safety with regard to traffic loads. After the test, it turned out that you have by far enough resistance. And that means a lot of money which has been saved by the right model. And if we look to the model code, we have this critical shear crack theory, where everything depends on the angle, the opening of the inclined crack. The larger the opening, the less the aggregate interlock contribution, and this is the physical realistic model. And it is not clear, well, it is physical correct, so that means you introduce this confining force. And it was demonstrated in this research program that it is possible with a combination of finite element analysis, and also Beatrice, she did also this analysis and showed that you can introduce this force, and then you can take that influence. And here we have, for instance, a diagram where the rotation is the opening of the inclined crack, and the punching capacity. This is the failure criterion. Here we have a slab without confinement and without pre-stressing. Here we have a slab with only pre-stressing, and here we have a slab with pre-stressing and compressive membrane action, and you see that there is a considerable increase in the capacity. So inherently it is there, but the people do not see it. And here I think we quite easily can extend this punching model to take into account this effect. And this is making the whole punching approach immediately much more suitable to existing structures, where we need this additional component. We have, with regard to shear, we have a number of levels. Level 1, level 3, level 2, and level 3 is mostly avoided by the people because you need some convergence. And especially if you have an existing structure, you don't know where to start. And here we have a very interesting structure. I remember that once we were in a technical committee meeting of FIB, and there was some topic which was not so interesting for me, so I was looking to this because they asked me, is it possible to design such a detail or to assess such a detail with the level 3 method? This is a reinforced concrete slab in the Steigenberger Hotel in Vienna, and the famous designer was Fritz von Emperger, and he came up with a design like this with beautiful bars and so on. And the funny thing was that within 10 minutes there were 5 people, Aurelio and Uro and Stefan Foster. They were looking and speculating about this detail. But the people had asked, is it possible to calculate it with the level 3 method? So I tried it, and it was, well, it takes some time. But it turned out that you have to start somewhere, you have to assume a load, and then you calculate many things, and then the load comes out. And if it is the same, it's good, and otherwise you have to go back. And after 3 circles, it was there, and it gave a good result. But people, nobody knows that this is possible. And people, of course, it's not a matter of that it is not there. It is a matter that people have not enough knowledge to understand it. This is also a missing link that we have to fulfill. So we have to give, therefore we have said we will make a bulletin with examples, and that people can see how you can use this to your profit. The complaint is sometimes that people say it is not operational, it is too much descriptional, and we can do something to improve that. But we do not have to change too much, we have only to explain. Another interesting case is this case where the structure has been damaged by alkali-silica reaction. And that was a research which was, I think it was the master thesis of Gerry. He was involved. And it's about 15 years ago, or maybe 20. But so slab bridge was damaged by a lot of horizontal cracks. And that was a very interesting consideration, because in those days we had a very simple shear capacity formulation. It was said that the nominal shear strength is 0.4 times the design tensile strength. That's all. And you can imagine that people want to know the strength, and they started to drill cores from the bottom. And then you see the horizontal cracks here, right? Horizontal cracks everywhere. So you drill a core, you remove the equipment, and the core falls down immediately. And then people say this, that means that the tensile strength is 0. And if you put that into the formula, also the shear strength is 0. So we have to demolish that immediately. And the tests have shown that this was not true. These are beams sawn from an existing bridge, and the capacity was much higher. In those days, we said it was 0.7, but with Thierry, in the weekend, he did another analysis, and he said, if I compare it with Eurocode, it's 90%. And now we understand also why, because if we have cracks which are starting here, and the incline, the larger inclination is here, it finds out that there are horizontal cracks, but the lower part, which is most of all responsible for the capacity due to interlock, is not very much changed. So now we understand why we can expect that such a damaged beam is not a big problem. And also here we can say we should be able to analyze that. And here provocationally I have added another factor, KESR. But of course, this is not realistic. But we can, with simple means, we can adapt our models to an existing structure. There's only good considerations, and we can use the models that are there with a little extension. This is not true for everything, to my opinion, because the big point that we have in model code is that we design not only for now, but the factor of time is included. We design for service life. We have to make sure that the service life is at least so much. And we have models for service life, and this is a very famous one by who says that if I have a structure, I need time so that chloride ions are traveling through the cover, so that finally there is a certain critical chloride concentration, and then the whole process starts. Well, there is rusting and longitudinal cracking and spalling off and so on, and then it goes quickly. But this is the end of service life according to the most recent opinions, and we have beautiful mathematical formulas here. This is the probability, and this is the critical volume, and this is the volume which is really there, which can be calculated, because here we have the cover and here we have the time. And here we have Fick-second law, which is mostly used for this analysis. You can calculate the chloride content at a certain distance from the edge, from the outside, and for a certain time. And one important parameter is the diffusion coefficient, and the diffusion coefficient can be determined by the rapid chloride migration test, and this has the ambition that in a short period, in a number of days, you can have an accelerated process so that you can calculate the real coefficient for the real structure. And this has been criticized already quite substantially, because people say, well, if you have a test of a number of days and you extrapolate it for 100 years, then you might be very outside of that region. But the idea is still that the chlorides travel through the cover. And the ideas are a little bit fake about it, because everybody speaks about cover, nobody speaks about crack. And in the older bulletins of the 80s, FIB bulletins, you see that you need two things. You have the crack, and you have the anode there, and you have the cathode, and it is only formed when the chlorides have reached the reinforcement. So this is the slower action. So you might calculate this, and that means it can be 50 years, and the crack does not matter. And this is what is in the codes. And this is very strange, because people fight to death which is the best crack risk calculation formula. I remember with Hugo, we were in the project team of the Eurocode, and we had a delay of 1 year because they were not agreeing on the formula. Finally, there was a compromise. And the strange thing is that somewhere else we have a table with the allowable crack width, and nobody looks to this. It's not important. And where it is coming from, nobody knows. Because also there we said, well, what shall we do? We take it what was in previous code. And this is very crazy, that we have limitation of crack width, and we don't know why. Well, it's interesting. So we have done a number of tests, and here you see the test. That is a beam, and the beam is bended upwards. So here we have the point loads, here the reactions. So here we have the cracks, and there is a reinforcement, and also the electric current has been measured to see if there is corrosion activity. Altogether, there were about 36 beams, I think, and here on the top we have some place where water with chlorides can be placed and removed. So we had cycles and so on, and also sometimes a little bit of cycle that the crack width moves from point 1 to point 2. And this is the PhD candidate, Andrea, and he's very proud of his results. And here we see already that we have cracks, and the cracks are showing already corrosion. But of course, this is a concrete which is not very high strength. It is about 20-25, and of course it is exposed to very severe conditions. And because he has only 4 years and he must write the thesis, so he needs quick results. But what we see here is quite interesting. We see cracks, and always we thought, well, the largest crack has the most corrosion. But here we see cracks which are very near to each other, and it has also substantial corrosion. So this is very interesting, and also his results are interesting. And finally, it was decided to open all the beams, so to saw them along this exit in the middle, and then to spray some fluid on it so that you can see which area is full with this chloride. And here we see 2 beams, and this beam is the uncracked beam. So we have the uncracked beam, and we can calculate with Fick's second law that the chloride front has, in 2 years, has reached a certain level and has not yet reached, according to the theory, the reinforcement. And here we have another half of the beam, and here you see the top, the tensile side with the cracks, and here you see the bar, and here you see the chloride. The chloride is not limited to the cup, but the chloride is already progressing to the other side of the beam. And that means that our idea to ignore the crack width is wrong. And I think, well, it is called the apparent, the apparent coefficient of diffusion. But I think apparent is very far from what we really see. And therefore, we have, I think, to revise these models, because anyhow we have to see why this is so, how good this is, and I think it is quite far different from the reality. And therefore, I think this will be reconsidered. That's an important task. So we have models. A number of them are good or can be extended, and a number of them should be more fundamentally reviewed. But the most important thing is that we have right input values. And for instance, the chapter 5.1 concrete in the model code has a number of chapters giving a lot of information, about 60 pages of information on time effects, temperature effects, multi-axial states of stress, transport of liquids, and so on. And now we have old concretes, and we have to make sure that the information that is needed to put into the models is also here. And that means that we can supply general relations, like for instance here, this is the degradation of mechanical properties due to alkali-silica reaction. But of course, any reaction is a little bit different. So you can give the general approximate relation, but we should maybe also give methods to how to measure, how to test these properties and to use them. And this will be an extension of the chapter 5, which is quite substantial, I think. We can use information from history. Here, for instance, this was a study at TU Delft from Gerard Gaal, and his task was to make a prognosis of the service life of the existing bridges. More than 1,000 bridges were regarded. And one important information was that the cover, the minimum cover as prescribed in the codes is increasing and increasing and increasing because people found out that we really need a big cover. So this information is very useful, and we should point out that things should not be overlooked. Here, the degradation of the bond strength due to corrosion, weight loss, a very general and approximate relation, but it is very useful to have first information. But in reality, we have to prescribe tests how to deal with this status. And so, as a conclusion, we can say that FIB Molecule 2010 can serve as a basis for the evaluation of existing structures. That we have a lot of good models. The models should be upgraded to take consideration of residual effects. More attention should be given to the development of high level approximation. In certain respects, more fundamental improvements are required, like the chloride contamination effects, the role of cracks for surface life. Maybe we should go to damage models, because the point is that if we have stress in a bar, then we have micro cracks around it. And these micro cracks, they are also a further facility for chlorides to travel to the bar and to go along. And also these cracks, they reduce the effective cover. So I think this is something to be reconsidered. These aspects can be taken into account by a working group which concentrates on upgrading FIB Molecule 2010 in general, because we just pointed out the aspects that are for us interesting if we regard existing structures, but also we have things like fiber concrete and FRP where we can say it can be improved. The most important task of DG2, but you can say that the task group in which organization we will do that is not so important, but for the new model code, it's to recommend how suitable input data for the models in model code 2010 can be obtained by measuring, observation, and testing. As far as possible, relations for the mechanical, physical, and chemical behavior of deteriorated concrete should be given. Moreover, recommendations should be given for procedures for testing the structure as a whole and determining the bearing resistance, including the remaining surface life, so including physical and chemical aspects. That's my consideration. So I give the word back to the chairman. Thank you.
The presentation of yes, Aurelia, and after we can have a common discussion. Thank you.
So I think I can skip some parts because you have already shown more or less the same. In addition, I think here there are some ideas for the next generation, for the next FIB model code. I think perhaps we should try, nevertheless, we should try to have a code which is more oriented toward practical needs and perhaps more concise, because at the end we always say it is very comprehensive code, and if we take into account that model code is a basis for other codes, perhaps is the correct approach to have a very comprehensive code, but then it can reduce the impact because people have the impression that it is very complicated and not easy enough to use. And to me, this is perhaps a problem we have with the current model code. Perhaps we have to think about it. The current model code is already quite general, but I think it can even be more general and perhaps even be more based on mechanical models. And there are still some empirical equations in this code, and perhaps we should try to work on them. Perhaps we can also try to have a more systematic level of approximation approach. I will come later to this point. And then there is, of course, the question. To me, the answer is clear. Do we need more refined models or different models for assessment? To me, the answer is clear. In fact, I would like to say something about mechanical models and empirical equations. Here you can see a picture taken from this publication. This was the model by Wilhelm Ritter, quite old, for bending. Wilhelm Ritter already says that we can neglect tensile strength in concrete, we can neglect bar bending, and that we have to be careful with the nonlinearity in the compression zone. Quite old. And what we use today is practically the same. This is another publication, 50 years old, written by Theodor Zutti on the same topic, on bending. And Zutti did an interesting work. He tried to find out an equation in order to calculate bending strength based on regression analysis of beam test data. And this was the result. This was the result, the proposal by Zutti. I'm very happy that in the current model code and the Eurocode and all our codes, we have the Ritter approach. I'm very happy with that because it is possible to have bending in a very concise manner. And this is something which is very important. This approach is valid for several cross sections with axial force, with pre-stressing, with several reinforcement layers, with different concrete types. Can you imagine the Zutti approach for all these phenomena here? For everyone, we should add a part of the equation or additional parameters, very complicated. And something which is even more important, this approach can be easily adapted for unforeseen cases, for instance, non-metallic reinforcement or other cases, or FRP strips, or just to adapt them. This is for bending. Of course, Zutti did the same also for shear, 5 years later, 68. He came out with this equation here, also based on regression analysis. And this was the proposal by Zutti. It was based on this kind of tests. At that time, quite small tests, which means that he didn't have the side effect at that time. Well, in this case, he was much more successful because we can find the Zutti equation in the Eurocode and in former model code. And I think this is a part of the problem we have in the current approach in our code. I mean, this is the Zutti equation, but then we had to add the size effect, of course. We had to add the normal force effect, which is fully empirical. We needed to have a minimum value. The background is unknown for many engineers, which means that it's not always easy to use this limitation. And you can see that if we would like to adapt this approach for other cases, it will become more and more complicated. I think this is the problem. On this slide, I have summarized the problems we had to solve in our engineering office, which are related to shear of members without shear reinforcement. As you can see, they are quite different to the tests which have been used in order to calibrate and to derive the equations we have in the code. I mean, for instance, the influence of load distribution here, of the static system, for instance, clamp slab here, continuous slab, variable depth here, or here, or here, member curvature here, or here, concentrated loads near linear supports here. They're completely different, in fact, to these tests here. And to me, this is a big problem we have currently. What does it mean? That we have the practical needs, we have to simplify the problem in order to the danger is that we derive empirical equation from this test, and then we try to adapt the equation here to this particular cases, and then we have to add additional complication. I think the solution should be different. We should use this test here, not just a result, but we should use the measurements we have done in this test in order to understand better the load carrying capacity and the load carrying mechanism, to derive general equations, and then to generalize the model in order to have a model, a very general model, which can be used for all these cases here. Another example, punching of flat slabs. There are about 500 tests done in the laboratory which reproduce this portion here of the slab. Internal column, symmetrical behavior. In reality, it's a little bit different. We have this continuity. In many cases, we have edge columns, corner columns. But for edge columns and corner columns, which are very useful, in fact, we have provisions which are directly derived from these tests here, and just adapted for the corner and slab and edge columns. There are very few tests on structures which are a little bit more similar to reality. This is, for instance, is a test done at IMPA in Lübendorf in Switzerland some years ago, and we can learn a lot from this kind of test. It's a little bit of pity because there are only few tests similar to this one, but we can learn a lot, and we can try to derive models based on the observation. This is something very similar to what you have shown, Joost. This is related to redistribution of internal forces, because in fact we don't have a linear behavior, which means that we have a redistribution between hogging and sacking moment, which is very important, in fact, which we don't take into account. And another phenomenon which you have shown some minutes ago, it is related to expansion of this portion here of the slab. It is confined by the surrounding slab, which means that we have compression in this portion here of the slab, and we have a stiffer behavior. The nice thing is that we are able to take into account this phenomenon here with the model we have in the current model code, and this is very useful. We have done this work in a very systematic way, and this is the result of the work we have performed. This is the punching shear strength as a function of the reinforcement ratio. This is the curve according to model code if we don't take into account the this effect. The Eurocode the current Eurocode would give more or less the same result for this particular case. And this is the result we get if we take into account momentary distribution and compression membrane action. As you can see here, we have an important, very important hidden safety. Here is perhaps only 10–20%, but here we have 50–60%. What does it mean? This is very important for, of course, for assessment. But I think that this is also very important for designing new structures, because we are learning a lot. We are learning a lot when we do assessment and we do this kind of investigations. And in my opinion, we should also use what we have learned in order to improve our models for designing. Because why should we design here when we have this in reality, when actually we have these strengths here? It's a waste of money. So here are the conclusions. More general provisions are needed, not only for assessment, but also, this is very important to me. More rational models, removing core heritage from previous empirical design rules. We did an important step forward, of course, with the current model code, but further steps are possible and needed, in my opinion. More systematic use of level of approximation approach, for instance, anchorage strength. Anchorage strength can be done very easily in different levels of approximation. Time effect on concrete, also the same, can be simplified for very simple cases. Deterioration. Is it important only for assessment? In fact, if you are able to predict deterioration, and if we have the impression that there are some structural members which are sensitive to deterioration, perhaps we should even take it into account in designing them. Actually, it is exactly what we do for fatigue. We need more unified approaches, of course, and we need to remove some shortcomings. For instance, the difference between a fiber concrete and reinforced concrete. And perhaps this is the two most important tasks. I think we have to investigate in detail hidden safeties. Very relevant not only for assessment, but also for design due to economic reasons. I think we have to be careful, because if we have too much hidden safety, the risk is that reinforced concrete is no more competitive against other methods, steel structures. And this is a really an important, very important issue. I think when we have a look in a general manner, we can save millions and millions, in fact. So, which means that we have a big responsibility related to this. I think the time we will invest doing this work here is an incredible investment for saving money for the next generation. And this is, to me, also very important. I think we have to improve easiness of use. This is very important, because if you produce a model code which is not easy enough to use, then we will have not enough impact. Of course, I fully agree with you, Joost. The examples are very useful and needed. I fully agree with you. They are needed, but perhaps it is not enough. Perhaps we should try to simplify the provisions. Okay, thank you.
can start with the discussion. Any question?
I have a comment. You both raised the problem of considering loads in two-dimensional elements and the hidden safety that should be there, because actually we have a bigger experimental bearing capacity than the former. I think we have the solution in the model code in the moment. That is a level 4 for two-dimensional elements. If I consider the element of the analysis, a finite element, from an elastic analysis, for instance, I have to design in 2D following the principal shear direction. If I have this design implies that I have a tie which is oriented to the principal shear, projecting the two reinforcement. If I have not enough bearing capacity in one direction, that means that I can rotate the principal shear to give it equilibrium because I have enough reinforcement in the other direction. And this implies a equilibrium of top moment and bending moment. But it's practically the old Wood approach to redistribute the internal actions around the point of 2D. Then is a case I tested numerically, and it works. It's a case in which we have to give a suggestion to improve the redistributions in 2D and in 3D, because for the moment the code is essentially sound and refinement for 1D, but concrete structures are in 2D or 3D.
Yes, correct. In fact, there are two kinds of redistribution of internal forces. The first one, which is related to bending and cracking and nonlinear behavior due to bending. And we have investigated it in detail because we were able to measure the reaction forces, and we were able to measure the redistribution of the internal forces. We also did some nonlinear calculations together with Beatrice Valenti and students of Beatrice, and we have seen that the redistribution of internal forces due to bending, it exists, but it is not very important. We have seen that a phenomenon which is much more important is the redistribution of internal forces due to the development of shear cracks. And shear cracks are very difficult to take into account in a very consistent manner, which means that we still need a little bit more work. We still need a little bit more research. You say, I agree with you, this is level 4. But nevertheless, if an engineer is designing a bridge deck slab, we cannot ask him to use level 4, which means that we need a simplified method to take into account all these phenomena. And at the end, if an engineer has to increase the bridge deck slab of some centimeters, or even worse, to put shear reinforcement, at the end, the economic impact is quite important, and something is wrong, which means we really need simplified tools in order to treat this problem.
I think the solution is like for the redistribution of bending moment in the beams, to arrive to say the principal shear might be deviated of 5 degrees, 10 degrees. This should be useful for engineers.
For instance, for instance, and this is really a general problem, because more and more people calculate with using finite elements. A slab is usually calculated finite, and we need to have a rule in order to put limits for redistribution of internal forces. Because nowadays, for instance, for shear, people take the maximum shear force. We know that it is wrong. But how to take into account the potential redistribution? We need rules, and we need general rules, not only for this particular case. because this is very similar also for punching. When we have a column with a complicated shape, or when we have a concentrated load near a column, then we have a very similar problem. People calculate shear forces, and how do you take into account the redistribution of internal forces? This is an important task we will have in the next years, in my opinion.
Richard.
Thank you very much. I would like to thank you for your presentation, and I would like to underline the role of nonlinear finite element analysis when we are considering such a kind of redistribution that, together with experimental results, can help us to obtain, to better to optimize parameters we use for a simple level, lower level of approximation for the design. And also, I'm thinking when you show all the application on shear related also to interaction between shear, axial load, bending moment is. I think that the nonlinear finite element analysis can help not only for the assessment but also to help for the optimization of simplified calculation. That is the only remark.
Well, this is certainly an area where a lot can be won with regard to the accuracy, because we have, a few years ago, we did a very interesting experiment. So we asked even Benz from the USA to select 3 tests that have never been published. So, and then 5 teams of nonlinear finite element specialists were asked to make a prediction. And then we came together and the results were shown, and it turned out that there were enormous differences. And sometimes the reason was that people had not seen the right details on the drawings were not clear, but otherwise they had made other selection of the type of elements. They had taken other fracture energy and so many things. But then the ministry said, well, if we see these results, we can stop with finite element analysis because it's unreliable, absolutely unreliable. And that for us, that was the case to change the strategy and say, look, we should not just take an element or take a program and analyze something. We should also make tailor-made solutions. And well, you have also worked for this, and also a number of people here. So what we did was, for instance, make a program which is very suitable for the analysis and assessment of pre-stressed I-shaped beams. So a number of tests have been, well, they have been predicted, the behavior that was known, and calibration were made in order to be sure that for this particular type of beam, you can have a very, very accurate analysis. So you calibrate it in before. So in this way, you can improve the reliability a lot. And also there we have still, I think, a considerable way to go. This is a very challenge to improve the reliability.
If I can add a sentence, we always speak about robustness. We should also talk about robustness of finite element calculation, of nonlinear calculations.
Yeah.
Yeah, I would like to add something about compressive membrane action. We can apply compressive membrane action in the typical bridge test. We have prefabricated beams and small deck on top of it. That means that the permanent load is rather low, and we apply it to the variable load, which is only there for a short moment. I saw in your slides that you mentioned it for buildings as well. And to my knowledge, it was not allowed to apply compressive membrane action in buildings because the permanent load is always there and is perhaps 50% of the total load. And it appears to be that time-dependent effects like creep will affect negatively the compressive membrane action. So for that reason, in the Netherlands, but also in the past in the Canadian code in the 60s, they did a lot of work. They did not allow it for buildings and only for bridges where the permanent load is rather low and the variable load is the greater part of the load itself. So I would like to add that to the suggested slide over there.
Yes, thank you for the remark. This is a very, very important remark. We did this analysis, and we did also sensitivity analysis. For instance, we investigated the influence of shrinkage, we investigated of the influence of creep. For instance, reducing the young modulus of concrete, and we have seen that the influence is not very large. But of course, we have taken it into account, of course.
Can I make a comment? With BRE, we did a test on a building, a 7.5 meter grid. It was a test building. I think the slab was 250 for a 7.5 meter span. Did a fire test with plain bar, well, not plain bar, straight bar. And due to the spalling went beyond the bottom level of rebar, and the rebar dropped out. So you ended up with a slab which was resisting the load purely by compressive membrane action, and it stayed there for 2 years under the test load, quite happily. So
but here again we need to have a model to take into account this effect. We cannot perform a test like this and say we have additional 70% strength and then put a factor of 1.7. Because
I'm not suggesting that we
I know. And this increase very much depends on the reinforcement ratio, of course. And I fully agree with you. We need to take into account creep and shrinkage in this calculation. But we have the tools to do it.
Well, perhaps I can add a little bit more. We did also a test on fatigue in combination with compressive membrane action, and the reduction was very large. So we have the intention to increase the number of experiments to take into account the time effects. So we used 1:1, not to include compressive membrane action in those situations where the permanent load has a greater part in the total load. And I fully agree with what was said about past experiments where we have no reinforcement at all. It was just oxidated, and it can rely only on compressive membrane action. But we have to take into account the reduction versus the time effect.
Thank you. I have slightly different issue. Yeah, since we are talking about the punching shear strength. I haven't seen similar problem in other countries other than Japan and Korea, but we have punching shear in the bridge deck. It's quite different from this flat slab case, and we believe this is the effect of the traveling load. And probably for some reasons in European country, you have thicker concrete slab than the Japanese concrete slab, but it's quite serious problem in Japan at this moment. It really could happen if your concrete slab is somehow thin, then you may have punching shear strength under traveling load.
Yes.
And maybe next another call we have to include this aspect.
Yes.
Thank you.
I know the work done in Korea and Japan, very, very interesting. For instance, in my country, it was when I studied, I learned from Professor Mann that bridge deck slab has to be between the thickness of a bridge deck slab has to be between 16 centimeters and 20 centimeters. at that time. And then we increased, and now I have the impression we are a little bit too thick, probably, mainly due to shear and punching. And I'm not in favor to come back to 16 centimeter thick slabs. But in the middle, perhaps it would be a good compromise.
Just have a small additional comment. I was just thinking, you talked about compressive membrane action, but while you are talking about hidden safeties, there's also tension membrane action. But that's, I think, even worse to predict at the moment. And there we are even, I think, further away from real design equations. But I want to warn a little bit, because some of the observation we had with the tensile membrane action, and I'm not sure whether this is already taken into account in the investigations which are currently done on compressive membrane action. But if we take a look at tensile membrane action, the uncertainties start to play a very important role, because there is a lot of scatter also in the results. I don't know whether you also see this in the experiments, but what we noticed from the preliminary investigations we did on tensile membrane action is that you could have a model which on average is having a very, very large hidden safety. And so you would be triggered to say, okay, let's take this into account, and on average this would be so many additional percentage that we can gain from applying it or take into account the tensile membrane action. And if you then take into account the uncertainties on the properties which are involved in the modeling, you could end up with some or less the same results as if you would not take it into account. And I'm not sure whether this already is considered, but this might be a very important item to discuss and to think about before we end up with proposals to take membrane action, compressive and or tensile, into account in all kinds of situations. I'm a little bit, but from what I saw for tensile membrane action, I'm a little bit hesitating whether this is already the time. I'm not sure for compressive membrane action whether you see also the same scatter due to variations in parameters.
We are talking about two different problems. I mean, compressive membrane action is related to what happens in this portion here of the slide, and this is particularly relevant for shear and for punching. What we're talking about is more relevant for bending. I mean, if you have large deformation, and we have this effect even for very, very small deformations. Some millimeters displacement are already enough in order to activate this compression membrane action, because this is very stiff. Tensile membrane action is very important for bending, and we activate it for very large deformations. And I think this is not important for the ULS. It is much more important for the robustness. What happens, for instance, what happens when we have a shear failure? Then we can activate tensile membrane action, and then it is very relevant. But I mean, this is another matter. And when we are talking about robustness, perhaps what we are talking about is very important, of course, but perhaps less relevant. But I agree with you.
I was interested in your comment about the fact that we should take advantage of these hidden strengths in design as well as assessment. And you also talked earlier about the importance of engineering judgment. And I guess over the years, I've taken a different view on assessment than the one on design, applying judgment. That if you're assessing an existing structure, one works very hard, or should work very hard, to identify those hidden sources of strength. But in a design situation, I haven't felt the same drive to try and do that. And I just wondered whether what your views are, induced on your K1 and K2 factors, but for punching shear or shear strength in slabs. Are those things that we should be looking to use in design as well as assessment, or how should we be? What should our philosophy be when we think about this? And I wonder whether actually coming back to something you were talking about sort of incremental cost and issues of robustness, because I think we know that in some structures it doesn't actually cost us very much to put in a little bit of reinforcement that gives us a very significant improvement in robustness. And I just wonder what your thoughts are on how we should be dealing with that if we do move towards a more unified code.
Adding reinforcement in order to increase robustness is a very interesting problem. For instance, in our national code provisions in 2003, we decided to put a provision asking for integrity reinforcement over the column. And we were quite happy with this provision. And then we thought that actually we needed too much reinforcement for very little increase of robustness, because we have performed tests and tests and tests, and we have seen that it is a reinforcement which is used practically only after punching. And I'm not sure it is the right way to solve the problem. And then we have performed another research, and we have seen that if we add the shear reinforcement here, we have two advantages. We have three advantages. We can increase strength, we can increase deformation capacity, which is very important for robustness, and we can increase residual strength. As soon as we have punching, then we can, if we have shear reinforcement, then we can activate the membrane action of the upper reinforcement instead of putting additional integrity reinforcement on the bottom side. Answering to your question, I think it is very interesting and very useful to put a little bit more reinforcement in order to increase robustness. But we have to be very careful that you put it in the right manner. And the best is that if we can use the same additional reinforcement, not only for increasing robustness, but also for ULS or SLS. And to me, this is really the engineering task. Put a little bit more, but use it not only for robustness, but also for other purposes.
Some very interesting other aspect. You said we should not use too advanced models in the design stage. Should we? Yeah, should we? Because we should realize as well that 60% of the concrete in our building is in slabs. And if you see how slabs are designed, you assume something and you put reinforcement. And I think we are speaking about sustainability. And I think there is an interesting task to see how we can reduce the slab without giving up the robustness, but with a lot of in the sense of sustainability.
Justin?
Yeah. Very good presentations, both. But I would like to say reality is very complex. We are talking about many problems. You have said that Leonard didn't want to see some results because they were not good for his own ideas. We are talking about compression membrane action, tension membrane action, many things. But at the end, we need to help we are talking about how we can make cost-efficient design, but at the same time, in my country, for example, we started spending a lot of reinforcement because of the cost of the labor, more than of the formulations we were using. So we need to try to take into account all the concepts at the same time. And we need not only engineering judgment, we need experience. We need, along the time we were learning a lot of things. For example, I learned well the tension membrane action after the terrorist attack in Madrid to our airport. And you see there perfectly how is a good way to resist extreme loads. So what I want to say, I don't want to lose our goal. I want to return to the aim of our workshop. We need really to improve, even a little bit will be useful for the designers. We are talking about design, we are talking about many things which are very difficult because to analyze in one day. And we have a good document, we have good ideas. We don't need to solve all the problems today in 5 years. We need only to make a small evolution. I want to ask you not to lose this goal. We have a project, and we need to solve the problems we can solve today, and it will be useful if we can tell people we are not able to solve all the problems. Be careful, because we have doubts. When you design, you can make structures better if you avoid structures. You never solve the design problems making calculations. You improve your structures making good decisions without calculating anything, with knowledge, not with models. And in some cases you have knowledge because you have seen a terrorist attack, for example. So I want to ask you to be careful. We don't need to lose our main goal. We need to improve our document. We need to cover existing structures. We are not able to solve all the problems. This is my personal opinion.
It is underlining the need for a good chapter on conceptual design.
Yes.
But, Hugo, I agree with you, but it should be not forbidden to be ambitious.
Yeah.
But at the end, I agree with you. We should be realistic. But perhaps we should put some principle on our goals. To me, there are some principles here. I mean, this one is a very simple principle, and to me, this is very important.
But communication is another problem.
Of course.
Business is against good communication of the concept. So we need to do
Yes.
our best. But
Yes.
we need not to forget our main goal.
Of course, there are some points are very ambitious, and some points here are very easy to do. I mean, for instance, this is very easy to do. Really, this is very easy. This is a very easy task.
I agree with you.
We should do it. This to me is very important.
That you have to delay, sorry.
I have
Last question.
one remark, which is actually a little bit related to what Joost was saying also. We do have 60% of the structural elements as slabs in buildings, and they are normally not shear reinforced. And we do have more than 70% of unreinforced tunnel linings. So for unreinforced concrete, we need a rational model, probably based on principal stresses for shear. And such a model, bending, shear, and so on, they can be used also to check finite element analysis.
Okay, thank you. We can.
Short comment. Short, very short.
Please.
No.
Very bullet.
On the robustness, we must be careful, because robustness cannot achieve the increase in the reinforcement in principle. Robustness needs ductility, and the increase of reinforcement generally reduces ductility. The best way is to give ductility to have an alternate load path. But if we have no robustness in the structure, we are obliged to over-reinforce some critical elements, but it's not a good way for the robustness. Then the robustness is in the mind of the designer, which conceive a structure which is ductile in principle and do not need to have critical elements over reinforcement.
Okay. There's one thing very interesting is that the steels that we have used in the 40s and the 50s were much more ductile than the steels.
Integrated robustness.
We have definitely something to discuss over the lunch. So you are very much welcome to go back to the lobby. We will have the lunch break until 2 o'clock. And once more, if any one of you wants to print his boarding card or anything else, we can do it during the lunch break. Just let us know. Okay, no problem.
Calcoli con il carico con i e non tieni in conto
Let me do it again. That's all right. Let me just take this. Okay, I'll take this out.
Very nice of you, thank you. It feels like Christmas.
Oh, thanks, man. I miss it one.
But the difference probably is in the degradation.
e sotto 20 tu hai un basso
No, claro, era una comparazione tra una partita adesso.
Hai una space in base. Nessuno attrezzi. No, ma completamente, questo deve essere un po'
sì, perché altrimenti
Yeah, I will leave the other one. Remember.
Poi il valore di una certa percentuale, no, era poi.
Okay.
Cioè il fenomeno è uguale. Se tu comprimi o metti copri di armatura e riduce le informazioni. Quindi queste cose non sono
Yeah, I already raised it by 3 degrees, but don't take a jacket, it's too hot today.
Sì, questo problema grosso problema
Issues where there is really a reason to discuss, and which we are not fully agree on how to proceed. So we will organize some workshop